Good morning to all. Good morning to our eminent guest speakers, Dr. Shruti Kanga, Coordinator of Center for Climate Change and Water Research, Dr. Suraj Kumar Singh, Coordinator of Center for Sustainable Development, faculty members, and to all who are present here from different institutions and countries. I, Priyanka Roy, welcome you all on behalf of Suresh Gyan University on the third day of 7th Annual International Convention on Climate Change and Water Research. This year's perspective of convention is sustainability in current scenario, challenges and solutions, with the view of building sustainable society for future. We are very delighted and eagerly looking forward to have you all involved in the quest of embracing knowledge. Now, taking forward today's session, I would like to introduce our first keynote speaker, Dr. Ramesh Narayan Gardas. Dr. Ramesh completed his education with BSc, MSc, and PhD in chemistry from Gujarat University, Surat. His work on thermodynamic studies of non-electrolyte binary and trinary liquid mixtures had awarded his PhD. He joined IIT Madras in the year 2010 as an assistant professor in chemistry and promoted to associate professor in the year 2015. He has more than 19 years of research and teaching experiences. He has many patents under his name, book chapters, over 100 research papers in international reputed journals with very high citations. Now, on this thought, I would like to invite Dr. Ramesh Narayan Gardas to take forward today's event. Sir, you are most welcome.
Yeah, good morning. Thank you. Please give me a minute. I am logging in through another device. Just 1 minute.
Sure, sir.
Yeah, let me share my presentation. Is it visible, madam?
Yes, sir. It is visible, sir.
And voice is okay.
Yes, sir. It's absolutely clear.
So let me start thanking the organizers for the excellent opportunity. I would like to thank whoever the involved directly and indirectly for this international convention. And my title of the topic is written Environmentally Benign Solvents for Sustainable Development. So I will be focusing more on the requirement of the solvent and the role of this solvent in sustainable development. So without wasting much delay in time, let's go into my talk. And I put a logo of my institute, my department, and the organizers of this C3W, they call it shortly the center, and the Suresh Gyan University gave an opportunity for me to present my work in International Virtual Convention, which is shortly called SCSCS 2020. So my email ID is here. You are allowed to ask me any kind of question at the end of the talk, or if you miss the chance or due to time or whatever, you can drop me email at gardas@iitm.edu. Let's start the talk with the blessings of the goddess of knowledge and the goddess of wealth. For execution of any kind of research project, any kind of research work, we need novel ideas, sufficient knowledge to execute it, and we need adequate amount of funds to convert that ideas into the reality. And I would like to dedicate this talk to this 17 color logo. Many of you might be aware this is a United Nations Sustainable Development Goals logo. Start from this red one. Let me put the point here. Start from this red and this all the way 17 colors to the deep blue. Each one of them present one goal. I will come to that in the next slide. So, United Nations Sustainable Development Goal, if somebody asks what is sustainability, it was decided long ago. I'll read from here. To meet the needs of the present generation. Up to here it is fine. To meet the needs of present generation. But the next sentence is also very crucial. Without compromising the ability of future generation to meet their own needs. So any development you want for your own need is fine, but that should not lead to compromising the ability of the future generation. To tell in much more detail about what is sustainable development. Any development which is economically viable, environmentally acceptable, and socially equitable. So the industry should get profit, environment should not damage, and all varieties of the people, middle class, lower middle class, upper middle class, lower class, upper class, it should be reachable to all. So this is the one of the acceptable definition of sustainable development. To repeat, any development to be called as a sustainable development should be economically viable, environmentally acceptable, and socially equal. So these are the 17 goals for the United Nations Sustainable Development Goal, it's called. And the target is 2030. So UN requested all the countries ministries and societies and the researchers to work on this. Today's my talk would be focused on a few of these sustainable development goals, mostly on 9 and 11 and 12 and few more, 7 more. Apart from these sustainable development goals, chemistry has a key role to play this development of 17 sustainable development, because this is a central science merging or going through or bridging all kind of other related science like chemical engineering, environmental engineering, forensic science, biochemistry, atmospheric science, medicine, agriculture, and so on. So chemistry has to play key role in using the less stuff or damaging the environment, or how to convert your reactant to product with 100% conversion rate, or without byproducts, or without any hazardous. I'll give one example. There are so many examples how chemistry has to play key role. Various examples are. Tell one. This is a periodic table of smartphone. There are more than 50 elements of the periodic table are involved in making the smart devices, smartphones or laptops, or be it a screen or a battery or a processor or the out layer polymer casing. I have color coded it here. This all these are saffron color are in screen, blue are in battery, green are in processors, and the deep red are in PC. Just to so when you want to convert device from the scratch up to the what you call the customer's hand, you need to understand all these 50 elements, properties, how they behave individually, how they behave in composition with others, how they can sustain to the harsh environment like temperature, pressure, and humidity and other conditions, how they behave in presence of others, how they function. So the knowledge of chemistry is very, very essential in process and product design and also. So apart from taking care of environment, I told you the trio, the three trio, environment, economy, and social risk. This is one trio. Now, the second trio is to execute any ideas into reality or creation of any innovation or execution of that innovation is always required a good collaboration. Collaboration between academia, industry, and the government. So academia can be collaborate within academics, within same department, same institute, other departments in the country or across the globe. Because future is working together unlike minds. Whatever intelligence or the expertise one has in a single field is not enough nowadays. You need to discuss with the unlike mind people and the different disciplines. And that's where academic sector has to play a key role. Also to understand that the national policies, international policies, when their work goes to the international level, also to bridge the gap between industrial research requirement and academics. Of course, you need a support from directors, deans, and vice chancellors, and head of the department, center heads, and the seniors in the department. Local support is very, very. Industries has to play a key role. They should understand academic people are spending a lot of their own time, their own academic research, so they should come up with more and more corporate social responsibility and setting up the labs or the sophisticated instruments in the academic and to understand their problem and work together. So no need to repeat the same work. Academia work something and again industry repeat the same thing because they don't believe their results of academia. Because academia is always oriented by publication oriented or the degree award oriented or the promotion, whereas industry is always profit oriented. So both should go in hand in hand. And of course, government has to play a key role, especially spending more money or recruiting academic people or bridging the gap between industry and. This is a second track. And always remember, you protect nature, then only nature will protect. Sustainable development is very much important. If you see the petrochemical based solvent market, annually more than 37,500 kilotons of solvents are used every year, and it is compound annual growth rate of 4%. All the places, it's not like South America, Middle East, or Europe, or North America, or Asia Pacific region. Everywhere it's the same. More than $50 billion market. All this because of significant growth and demand of this petrochemical solvent based market is due to mainly three sectors: automotive, industries, construction industries, and the third one is energy sector, automotive sector, and construction. However, stringent environmental regulations coming into force, and industries are forced to look for alternative to this petrochemical based solvents. They may go for bio-based solvent or green. So these solvents which are widely used are ethylene, propylene, methanol, xylene, benzene, toluene, butadiene, among the others. And the industries would like to replace them with nature friendly or close to nature. So nature friendly will be close to nature. So it's a bio-based alcohols, biodiesel, derivatives. One of the solvent, bio-based solvent, which is came in the market and become very popular in short time of last 3 years, so or 2-3 years, not much more, is serine. It's derived from levoglucosenone or coming from cellulose. This is capable to replace other dipolar orthotic solvents or NMP or DMF. The problem is the cost. Of course, cost can be reduced or we can come for alternatives later on. First, there should be some alternative available. So, with this background, let me start my talk. I am from chemistry department at IIT Madras. We have a beautiful campus. There are around 10,000 students, 16 departments, and about 600 faculty. Please do visit IIT Madras. So I would like to thank all my research scholars, those who are in the board, they have graduated and now they are postdoc in abroad or serving as a faculty across the country. Few postdocs and my collaborators within the department, within the institute, outside the institute, in the country, in India and abroad. And above all, I would like to acknowledge the support from my department, my institute, and the funding agency. Without money, we cannot do anything. Of course, the Suresh Gyan Vihar University and C3W Center for this opportunity. I have taken most of the images from various websites like American Chemical Society, Royal Society of Chemistry, United Nations, and some are from Google. I didn't acknowledge them every place, but I do not own copyright of any. All are from elsewhere. Of course, my work is there and my work is already published. So unpublished work is very less, which I will tell you. So let's begin. Why we need to look for alternative solvents. And I will introduce today new topic as alternative solvents called ionic liquids. I'll tell you this is a old wine in a new bottle. The trend is changing or mommy returns, whatever we say. So I will also talk about recent advantages and then what is our interest. If somebody asks, what is green chemistry? Define in one line. Any chemistry or any science involving, I read from here, the design, development, and implementation of chemical products and processes that either reduce or eliminate the entire use or the new generation of hazardous substances. So it is all about removing or not using or not generating any hazardous substances during entire process, whether it is a design or a development or anything. It's a very simple definition. So no hazardous substances anywhere, neither in the beginning, nor during the process, nor at the end. So if you see green chemistry principles here, today's our talk is mostly going to focus on the fifth one, that is safer solvents and auxiliaries. There are 12 green chemistry principles. I'm going to focus more on 5. Of course, I'm going to touch the 1 prevention, 3 less hazardous chemical synthesis, 4 designing safer chemicals, and 7 use of renewable fuels. Similarly, we do have a 12 principles of green engineering. So even though I'm not going to touch many of them, but at least I will talk a little bit about prevention instead of treatment, designing for the separation, or maximize the efficiency, or output pull versus input push for the last 12 on renewable rather. So now I told you three numbers: one, 17 sustainable development goals; two, 12 principles of green chemistry; and three, 12 principles of green engineering. Nowadays, if you write any project proposal for international or national or anything, especially international project, they ask you, or if you write your research work is going to address sustainable development goal number 12, or we call in short SDG 12, or green chemistry principle 5, or green engineering principle 12. So this way, this will create more impact and give a better impression that you are aware of the problems and you are going to address the solution, or at least you are attempting to address the larger. Now, coming back to the solvents, if if I can divide all industrial processes into three categories: solid state, solvent state, and the gas state. If I may divide all the industrial processes into solid state, liquid or bulk or solution state, and the gas, I believe most of the processing, whether it is in academic research or in industrial research, are in bulk phase or solution phase or liquid state. Maybe due to easy handling, easy stirring, easy transporting, easy to handle the temperature and pressure or other input parameters, or cheaper compared to others. Solid states, we have always a problem of heat dissipation or uniform mixing or uniform stirring or uniform. Similarly, gas phase is always we have a problem with handling high pressure or leakage or anything. So the bulk phase are dominant. Having said that, any process, even your bulk phase or the solution phase is dominated, you are using solvents. And whenever you are using solvents, the biggest challenge is due to their volatile organic nature, they evaporate very easily. And they may not dissolve in water, all of them. So the aqueous solubility and the high vapor pressure is the biggest challenge with the volatile organic compound. And due to this, due to low solubility in water and high vapor pressure, they are the major contributor for various problems like air pollution, ozone depletion, global warming, climate change, human health related, and so on. So what one should do? You use non-volatile or less volatile, or avoid using volatile organic compound, or use less toxic one, or use renewable one, or do not use the petrochemical based one, or try to look for a low vapor pressure or high boiling point or aqueous or water. But this may not be possible always. If somebody asks what is the ideal replacement, the solvent must be low volatile, high physical and chemical stability, high potential to recycle in number of times you can reuse, and should not lead to other complications. Above all, for any business, low cost and high. I will say this many. Why we need to worry about solvent selection? Solvents are very, very crucial in any chemical process and product design. They are the useful to modify the solute properties, either pH or pK, or redox potential, or hydrogen bonding, or they are promoting the what you call reactant to product, either by removing the impurities or by removing partitioning or byproducts, or isolating the product, or promoting the chemistry through various things. And the right solvent is very, very essential. How we choose this solvent? There are various ways. And when you look for a new solvent or a green solvent, what are the challenges you face? One, you need different nature, protic, aprotic. You need different polarity, low polarity, high polarity. You need different basicity. And above all, the combination of all these things. You need protic, basic, low basic, high basic, low polar, high polar, aprotic, protic, and so on. So when combinations are there, the pool of available solvent will go down and now narrow down. How you choose the solvent? As I told you, basicity, polarity, and the protic nature. Apart from that, you look for temperature window. How large temperature this solvent is in a bulk state. It's not converting into solid or not converting into gas, or it's not changing its own state or phase. What else you need? Functional groups. You see polarity, functional group, temperature window. We say no light, dissolve light. So you see various things. Now, apart from this, these are the general things, whether you look for polarity, temperature window, and functional. You need to look further deeper. Apart from chemical functionality or the functional group or the molecular descriptor, you also look for physical properties like melting point, boiling point, viscosity, conductivity, heat capacity, density, refractive index. So many properties you look into that, physical properties or bulk properties, macroscopic properties. Then you have to look for the environmental regulations and the legal controls. What is the impact on this environment and how safe they are to handle and for human health and environmental impact. Octanol water partition coefficient or toxicity profile or all. So when you have so many things to look at, how easy or how difficult to select a solvent for a particular process or product design. If you see Camlet top plot, basicity versus polarity for common aprotic and protic solvent, let's say non-polar one, you have a dichloromethane, dioxane, chloroform, diethyl ether, toluene, benzene, hexane, heptane, octane, decane, or polar aprotic means THF, DMSO, propylene carbonate, DMF, acetonitrile. These are the common solvents, mostly in energy sector, battery, and all other places. Very commonly used this. Ethyl acetate, tetrahydrofurane, and all. And also polar protic alcohols, water. You see the spectrum is full, but most of them are not good for environment. These are okay comparatively. The left hand side, these two, the right hand side one better. See, we have to look for much better, but this is okay. But problem is you don't have anything here. For example, if you want to replace this or this, you don't have here. Spectrum is empty. Okay, so how you will fill this entire spectrum? Whether it is benzene or chloroform or THF, you don't have very closely related. Some alcohols or some ethylene glycols or polymers are there, but we have to look for further and further, better and better. Sometimes you may go for supercritical carbon dioxide emission, but handling at high temperature and high pressure, both risky as well as expensive. So, as a scientist and as an engineer, we have to fill this entire spectrum with more and more and more and more solvents. If you see American Chemical Society Green Chemistry Institute website, I have copied it here. They have come up with the selection tool for more than 270 to tell exactly 272 solvents with more than 100 varieties of the option. How you choose the better solvent? You just put input parameters, parameter 1, parameter 2, parameter 3. You choose either physical property, you choose either functional group, you choose either environmental policies or health issues or how they are better and better. You choose all the options. You have 100 varieties of the option to choose. Then it will put descending order of the choice of the 272 solvents. Which one might be better under the set of given condition by you? And this is free of charge available on American Chemical Society Green Chemistry webpage. Of course, they have published this paper, but this website is more interactive and you can choose. Similarly, Chem21 from UK, it's a public-private partnership company. They have divided or distributed all the common solvents, so more than 150 solvents, into 6 categories. Highly hazardous, do not use. Hazardous, use with too much precaution. Problematic, be careful, if you can replace it is good. Slightly problematic, recommended, highly recommended. So 6 categories they have given solvents, and this 6 category they divided based on so many parameters like safety score, health score, environmental score, and then recommendation, and what are the families they belong to with the functional group, what are the solvents they are, and what is their liquid range, and how you can use them. So one can look for alternatives. However, this solvent pool is small. Let's say you are purchasing jeans pants last 20 years, and every festival you would like to buy new. So if the jeans selling companies won't come up with the new pattern, either in color or in design or in texture or in some extra facilities or new features, what you will buy? Not buy. You won't attract, or you may having more and more priorities and the competition. Same way, as the science is growing so rapidly, the requirement or the need or the combination of the properties are unique, coming new and new and new. For that purpose, you need to have a large uh, pool of solvents, so you may choose pick one better. If you have only 100 varieties or 270 varieties, it's not enough. So this Chem21, apart from this publication in Green Chemistry, they also have an interactive website where they keep updating this database based on this paper only, but you can find them alternative easy. So if somebody is looking for alternative solvents, so these 2 things are very important. One is ACS Green Chemistry website, and other one is Chem21 website, where you have almost 270 solvents entire profile. Is it enough? Answer is no. We have so many other solvents for which we are looking for equivalent alternative. Not only just 300, not only in pure state. I am going one step beyond binary mixtures or ternary mixtures, or each solvent in presence of other solvent. So the combinations are infinity. For this infinity combinations, can we have infinitive environmental friendly solvent? That's the $1,000,000 question. So some solution might come from ionic liquids. And we call this the old wine in a new bottle. Why we say so? Because this is a class of solvent, molten salt, known for ages. The only difference between molten salts and this one, let's say sodium chloride, called namak or meetu or uppu. It melts around 800 degrees Celsius. So that behaves as a molten state only above 800 degrees Celsius. Whereas we are talking about the salts which are liquid at and around room. That's the beauty. This new class of molten salts, widely known as RTILs, room temperature ionic liquids, or TSIL, task specific ionic liquids, or simply IL, ionic liquids. They have a potential to replace several volatile organic compounds used in many processes. The vapor pressure is negligible at room temperature and atmospheric pressure. They do have a large liquidous range. The flammability is extremely low. They have wide electrochemical window. This is very, very crucial properties in battery and supercapacitor and other energy sectors. They have high ionic conductivity. Solvating capacity is high for organic, inorganic, and organic metal compounds. And above all, great varieties of the structure. Theoretically, you can have millions of ionic. I will tell. So, other than telling old wine in a new bottle, now I have another word point here. Not me, it is known in the literature. Hybrid salts. Why I say hybrid salt? What is the difference between conventional salts and this salt? If you see any conventional salt, NaCl, KCl, KLa3, K2SO4, or anything you take, both ions, cation and anions, are inorganic in nature. Here, in most of the case, one ion is organic and another ion is inorganic. That's why it's called hybrid salts. Most of the time, cations are heterocyclic compounds like pyridinium, pyridinium, piperazinium, thiazolium, oxazolium, triazolium, pyrazolium, and mostly imidazolium. However, you do have other class like phosphonium or ammonium. Anions are relatively smaller. Start from the smallest halides, chloride, chloride, bromide, iodide, or slightly bigger, tetrafluoroborate, hexafluorophosphate, or slightly further bigger like dicyanamide or boron tetracyanide, or further bigger is trifluoride, or much bigger is bistrifluoride. So, due to the difference, large difference in size, when they come close together, they cannot pack together. However, that issue I come to later. So, cation, anion are plenty, so many options. Apart from this choice of two different cation and anion, you have a third variation is alkyl chain length. You can have methyl, ethyl, propyl, butyl, pentyl, hexyl chain length on cation or sometimes chain length on anion. So you have a three choice while selecting or making a new ionic. One, choice of cation, choice of anion. Third one is choice of alkyl chain length attached to either cation or anion. So based on these three varieties or three choices, theoretically, millions of ionic liquids feasible, at least on paper. On paper, millions of ionic liquids are feasible. Whether they really do form or not, that is the next question. If you compare conventional salts with ionic liquids or ionic salts and ionic liquids, as I told you, sodium chloride packed very closely on here, and the melting point is around 800 degrees Celsius, whereas ionic liquids, one example given here, ethyl, methyl, imidazolium, due to uneven shape or due to high unsymmetry, the ions cannot come together. Of course, they do have attractive forces, but very weak. That's where they do possess interactions and hold together. However, they cannot pack together due to symmetry, high symmetry, and large shape, and so they leave some void volume, and that's the reason they do exist in. Of course, there will be several reasons, but this is one of the main reasons. If you ask me, if I take a glass of water, okay, add salt in it, correct? You have ions, and your solution is in a liquid state. Can we call this an ionic liquid? The answer is no, because here Na plus ions are surrounded by OH minus or Cl minus surrounded by H plus. So we can call this ionic solution, not ionic liquid. Ionic liquid where cations are surrounded by own anions and anions are surrounded by own cations, and that's where they possess unique. That's the basic difference between ionic solution and ionic liquid. If you see the literature, organic solvents known number is very, very small, 300, 400, 500 or less than 1000. And they always used for single function, rarely for two or more than two functions. Whereas ionic liquids, millions of them are feasible if somebody wants to really synthesize, and so often they are multifunctional. All know ek tir do nishan or whatever you see. One role, dual nature. That's where they are very unique. Having said so great about ionic liquids, if some of you ask me, do they have any limitations? Yes, they do. To tell two most common or most worried limitations are: one, viscosity. Due to high viscosity compared to organic solvent, ionic liquid do have a problem, or you have to spend more energy for uniform mixing, stirring, heat dissipation, transporting. All this are limitation due to high viscosity. And the other one is cost. Cost is very high compared to organic solvent for most ionic liquid. We do have some ionic liquids where the cost is comparable, or some even cheaper when you synthesize in very large quantity. However, generally we can say most of the ionic liquids are highly viscous and costly compared to organic. But we can address both this problem at a time. That's what I was telling, एक तीर दो निशान. Instead of using them in a completely pure state, use their mixtures or use their solution either in water or in another organic solvent. So in that way, you are reducing the viscosity substantially and reducing the cost as well. Now you may ask question. All this is about replacing organic solvent. Now we are again talking about mixing them with organic solvent. How fair this statement or how fair this process would be? Well, if that question came to your mind, you're right. However, the overall use or the ultimate last stage product you achieve, instead of using 100% organic solvent, if you add little bit ionic liquid, if you can substantially reduce the amount of organic solvent required per unit volume of the product, if it reduces substantially, that's it, problem solved. Even though you are not addressing problem 100%, but you are achieving same targets with less damaging the environment. If you see, about 2 or 3 decades ago, ionic liquid research started initially as an electrolyte, then solvent, then extractant, then catalyst, then hydraulic fluid, then acid scavenger, and then heat transfer fluid, then fuel cell, solar cell. So on, it is increasing due to unique combination of their varieties of properties. It's like a hero who can make good jokes or comedy well, he can fight well, he can deliver dialogues well, and he also sings well. What else you need? So these are the few properties which are very, very essential one solvent should have. And the better one is the tunability as per application. You have three choices: choice of cation, choice of anion, choice of alkyl chain length. And due to these three choices, you are tuning the properties requirement for a specific application. That's where the unique nature comes. If you see SciFinder, the literature search shows there are more than 86,000 papers already published, more than 17,000 patents, more than 50 books on this field. Slightly lower number in Scopus, maybe because of some conference proceedings or book chapters of thesis or dissertations may not be included here, whatever the reason, but still the numbers are comparable. 72,000 publications are there. This is about 1 week ago. You see the number of ionic liquids papers in the open literature are keeping. Every year 5 to 6,000 publications. That's a huge number. One of the most popular review article appeared in Chemical Review a couple of decades ago in 1999. Already attracted more than 11,400 citations. A single paper in 2 decades received more than 11,000 citations. That shows the popularity of this field. And the author, Tom Welton, who is currently the president of RSC, Royal Society of Chemistry, who worked with the father of ionic liquid field, as Kenneth Seddon. I was fortunate to work with him at Queen's University Belfast in Quill, Queen's University Ionic Liquid Laboratory, Northern Ireland. And these are the few people who are in the topmost now. I highlighted 2 people, Juan Coutinho from Portugal and Chris Hardaker from UK, because I had a fortunate enough to work with under their direct supervision for my postdoctoral fellowship before joining IIT. If you see where the ionic liquid research is going, in India, so many people are working on, and we are contributing more than 7% of the global publication. Patents are there slightly behind, and books also slightly behind, but we do have. So China, US, Japan, and I'm sure in a couple of years, we may overtake Japan and we'll go to the number 3. Why I'm saying so? Because I am aware that more than 150 places ionic liquid research is going across the country. These are the few institutes where large amount of research on ionic liquid is going on. University of Delhi, BARC Mumbai, NCL Pune, IIT Madras, IIT Delhi, IICT Hyderabad, ICT Mumbai, IIT Kharagpur, CSMCRI Bhavnagar, BSU Varanasi, ISCS Kolkata, Shivaji University Kolhapur, IIT Govt, VIT Vellore, Guru Nanak Dev University Amritsar, and so on. IISc Bangalore. In University of Pune, NIT Surat. So there are so many places the research on this field going extensively. Not only in chemistry. You see the field, this attracted chemistry, chemical engineering, material science, physics, biochemistry, environmental, pharmacy, and so on. Molecular biology. Now you may ask a question if it is coming to your mind. How come a one field attract so many varieties of the discipline people? Answer is very simple. That's where I started my talk. What is that? If entire scientific process can divide into three varieties of the process: solid state, liquid state, and gas, if I may. So compared to solid state and gaseous state, solution state or bulk phase, science is known. And wherever bulk phase come into picture, solvents are coming, and solvents playing a key role. So ionic liquid field, this is a Iolytic German-based company. It is not only on the laboratory, not only on the publication, not only on patent and books. In reality, also the ionic liquid research has gone from the laboratory scale to R&D scale to pilot scale to commercialized scale. These are the few examples where green color shows that it is already gone to the commercial scale. Yellow one is a pilot scale, and this is a little bit old one. I think 6-7-year-old or maybe little bit more. I will tell you the industry scenario in 2020 or in 2019 at the end of my talk. Is another company, German-based company, BASF. They do sell ionic liquid for varieties of the applications, and this is the few old list. New list I will tell you later. So, what I want to say, not only in academia, in reality, in industry also, this has gone very substantially improvement and significant changes has been done over last 2 decades. So, in spite of this 72,000 papers, 17,000 patents, 50 books, still much to understand in this field. Most of the time, people focused more on application where replace the volatile organic compound partially or fully with ionic liquid, and just they say it is working or not working. Working, yes, working, one paper. Not working, not working, one paper. Why it is working or why it is not working? Systematic understanding through their structure property relations or through their thermodynamic understanding is still lagging behind. That's where we came into picture. Of course, accurate knowledge of these thermophysical properties are very, very essential and play a key role in cost-effective design and operation of chemical and biochemical plants. This helps to understand whether reactions are feasible or not, how much cost is required, what could be the size, what could be the material, how it can be, how to optimize these all parameters. Everything is based on precise measurements of thermodynamic and transport properties, without which it will not go. These are the basic input parameters for the Aspen or Cosmo or all of the calculations, or optimizing the volume, optimizing the parameters, or optimizing the design of the process and product plants. Of course, the accuracy depends on where you are going to use it, how much accurate you want. In market, there are so many companies selling ionic liquids. BASF, Cytec, Iolytic, Merck, Fluga, Sigma Aldrich, Tokyo Chemical Industry, Solvanic, and so on. However, we never purchased any chemicals in the last 10 years. For 2-3 reasons. One, what we want is a new ionic liquid. These companies sell only well-known and proven and large applicated ionic liquids in the bulks. However, we are looking for the new and new solvents. So new solvents may not be available there, and also even if it is available there, it's expensive. It is proven that you purchase raw material and synthesize in the laboratory, the cost can be reduced almost 10 times. However, synthesis is quite simple, so we can do synthesis of that. We are not a synthetic chemist, we are a physical chemist, but synthesis is easy, either by metathesis or by ion exchange or by acid-base neutralization reaction. Very simple ionic liquid synthesis, and we are happy to tell you that in last 10 years, we have synthesized more than 100 new ionic liquids, and we have repeated more than 50 non-ionic liquids. In this way, we were successful in synthesizing 150 ionic liquids. What we understood, synthesis is not difficult. It's easy. What is difficult? Two things. One, purifying them and then characterizing. More than this purifying and characterizing, handling them is difficult. So, purification stage takes extensive care and handling needs extensive care because most of the ionic liquids are hygroscopic and they take moisture when you open the vial in a fraction of a second. And due to this moisture and dissolved gases, many properties affect significantly, especially the transport properties like conductivity, viscosity, and so on. One has to be extremely careful. What we do purify them and use on the same day. While storing, we do store them under nitrogen atmosphere. And after synthesizing, we purify them, and after purification, we put it in a vacuum line and at around 30 to 40 to 50 degrees Celsius, and we stir it under what you call slink line, and liquid nitrogen will be there to trap any trace amount of impurities or volatile impurities or the moisture. And then after doing this purification stage for 24 to 48 hours, we store them under inert gas or nitrogen, and whenever we need this process, we will repeat. And we confirm with IR, NMR, and mass that whatever desired ionic liquid you want, it is there. And we also check the moisture content or water content, how many ppm it is there, through Karl-Fischer coulometric titration. After doing all this process only, we use them for either detailed study of thermodynamic properties or using them for a specific application. If we are going to use after 2-3 days, again we will confirm that yes, it has not been changed, still water content is same. So what is the thumb rule? The Lewis acidity of the cationic source and the Lewis basicity of the anionic source both are low, and the resulting ionic liquid will be 100% liquid. If both are high, even if you form the salt, it might be a salt. Or in mix and match case, you have to look for another interaction. Most of the time, we will focus on last 4 or 3 or 2, not 1. These are the few ionic liquids. Some of them are before purifying and drying and characterizing. Few are them after. After synthesizing, purifying, and characterizing, we study their thorough thermophysical profiles like volumetric properties, transport properties, acoustic properties, thermal properties, interfacial properties, refractive properties, derived properties, bulk properties, solubilities, phase equilibria, and so on. All these data are essential when this ionic liquid go from laboratory to the R&D to the industrial scale. This data will be the input parameter for process and product designs involving separation, heat transfer, mass transfer, and so on. Also, If you remember, I said theoretically millions of ionic liquid physical. Having said that, we cannot synthesize millions of ionic liquids and study their properties due to limitation of time, limitation of funds, limitation of human resources. And also, all synthesis and purification stage of ionic liquids are not green. Again, you may be damaging the environment. So, we need to come up with the predictive models. We take some class or relative class and some members of that family or the class study properties, and we extend these properties to larger range of temperature and pressure or the larger section of other members of the same class. So developing predictive models are very, very essential in developing new models or also validating available models. So these are our key thing: synthesizing new ionic liquid for a targeted application, studying their thorough thermophysical profiles, and developing predictive models. However, none of them I'm going to talk now. I'm only going to talk on application side. Before going there, these are the few instruments available in our laboratory and also in my collaboration laboratories and the department facilities and the sophisticated instrument, analytical instrumentation. I have not put all, but I have put just few: refractometer, density and sound velocity and viscosity meter, tensiometer, Carl Fisher titrator. We do have a new one also, conducting meter and heat capacity and rheology and so on. But if you see, everywhere I put this, whether it is analytical chemistry or physical chemistry or any science. Science is about revealing the truth. It has nothing to do with the right or wrong. No results are right, no results are wrong. It is about revealing the truth under given set of conditions. The condition might be temperature, pressure, composition, or other input parameters, or the purity of the samples, or other conditions. Conditions change, results will change. So the results are never we call the right results or wrong results. Results can be right or wrong. We never say. In science, is all about revealing the truth. For these conditions, this is correct. That's it. This may not be correct in other set of conditions. So, anytime you present your quantitative data, it is always essential to tell two things. Your data is under what condition? Conditions might be most probably temperature, pressure, composition, and the purity of the sample. That is very, very essential. And apart from these conditions, what else you will mention? The confidence level. At what confidence your data is, or what is the combined error? Any data presented without having a knowledge of any error or accuracy has no meaning. And it has to be presented in a significant digits. It has to be presented along with the error, along with the set of conditions. Okay, having said that, we are happy to announce in last 10 years or so from IIT Madras, from our laboratory, we have contributed more than 7,500 acceptable data of thermophysical properties of various ionic liquids, which are included in freely available IUPAC Ionic Liquid Database project. This is from International Union of Pure and Applied Chemistry supported project done by NIST people, National Institute of Standard and Technology, Boulder, USA people. They have gone through the thorough parameters, purities, and the conditions and everything, and recalculated the error associated, and then they have approved and included in this one. So anybody, earlier I told you two websites. Anybody would like to look for a solvents, this one, I told ACS Green Chemistry website and RSC Chem UK Chem 21 website. Now I'm telling you third.
Sorry
Yes.
to sorry to interrupt, sir. I'm very sorry to inform you, sir. We have little time constraint,
Yeah.
and yeah, sir.
5 minutes or 2 minutes or 1 minute. You just tell me.
Sir, another 5 minutes, sir.
Okay, 5 minutes I'm closing. 5 minutes I'm
Okay, sir.
closing. Okay,
Okay, sir.
thank you.
I'm
Thank
so
you.
sorry, sir.
No, no,
Thank you,
no
sir.
problem. No problem. No problem. No, I thought 1.5 hours. No problem. 5 minutes I'm closing. So the third website is IL Thermo Holder website. This website. Here you can see all the ionic liquids, more than 2000 ionic liquids, and what are the properties already studied. So we contributed in database, contributed in designing new ionic liquid and understanding their properties for targeted applications. Having said this, I will tell you all our synthesis and studying properties and developing model was a core expertise. All this has done for a specific application with the specific team. As I told you earlier, trios, one, industry, academia, and what is the third one? Industry, academia, and government should work together. Also, I told work should be economically profitable and environmentally acceptable and socially equitable. So trio 1, trio 2, and the trio 3 is reduce, reuse, and recycle the solvents. So these are the three important trios. Keeping this in mind, our most of the work are through collaboration with the various other people like chemical engineer, mechanical engineering, petrochemical engineer, and metallurgy people, also with the industries, ITC, Oil India Limited, and all other things. We have done so many applications in the last decade or so, whether it is dissolution of tank bottom sludge, enhanced oil recovery, metal ion extraction, or lanthanide actinide separation from high level liquid waste, or vapor absorption refrigeration system, solar refrigeration system, or thermal storage fluids, or polarity of liquids, or energetic ionic liquids, or electrolytes in supercapacitors, or batteries, or Dyson solar cells, or so on. I will glance through in next 3 minutes or 2 minutes and conclude in 1 minute. Tell what I want to say. This is industrial project from Oil India Limited and combined project with petrochemical engineer, my colleague Jitendra Samoy and me, and where we have addressed the dissolution of tank bottom sludge, and what we proved, conventional toluene or dodecan, when you add small amount of, these are the confirmation through UV, IR and NMR, that enhancement in the dissolution is more than 50% when you use trace amount of ionic liquid. The reason is the asphaltenes or the resins long pair attacked by IL cation or anion and made them to release aromatic and aliphatics. That's the key role of ionic liquid, and the remaining thing done by the solvent what you use. So whatever solvent you are using, toluene or dodecan, add a trace amount of ionic liquid, solubility will be enhanced 50%. That's the amazing results. Gave 3 patents, 3 to 4 publication, and 1 PhD degree for a student. Similarly, for oil recovery, tertiary, primary is a natural one, secondary is a steam or water one, and the tertiary one. With the conventional surfactant and polymer and other thing, if you add a trace amount of ionic liquid, enhanced oil recovery is enhanced from 52 to 72. That is 20% enhancement has been observed, and the reason is interfacial tension decrease. The tension between hot water and crude oil, or the steam and crude oil, or the rock and crude oil decreased substantially by adding a small amount of ionic liquid. This decrease we noticed from 40 to 10 millinewton per meter. This is a water and ionic liquid, and this is more than 56% decrease. And this decrease is the responsible for 20% enhancement in the recovery of oil. So what I mean to say, how a simple thermophysical properties knowledge is essential when you join hand with industry and other unlike-minded scientific people or engineers go to the application. So the basic science is fundamental science is essential for the applied science. Similarly, high-level liquid waste has a trace amount of lanthanide and actinide, and instead of conventional solvation mechanism, when you use ionic liquid, in addition to solvation, you have cation and anion exchange. So you can threefold increase the extraction of americium and other trivalent lanthanides and actinides. And this is very, very essential. Similarly, we have also developed the role of ionic liquid in vapor absorption refrigeration system, where at room temperature it absorbs ammonia and release at high temperature. And you can see that the coefficient of performance is comparable and circulation ratio is also slightly high, but it's comparable. We showed the role of co-solvent adding to reduce the amount of ionic liquid and the cost. Similarly, we have come up with the polarity of the ionic liquid, which are much more polar than water by inclusion of trivalent heterocyclic compounds and the triplet. And in polarity competition, they are much better than water and alcohols. And also, we were the second to next to the Japanese group of Ono to show the correlation between refractive properties and the solvatochromic properties. Anyway, we also show the heat transfer fluid or engine oil comparatively better than the thermal in all properties except viscosity. Hopefully, we can address this also in future. Similarly, we have done for electrolytes in the dye-sensitized solar cell and aqueous biphasic system extraction. We have taken model compounds like amino acids, alkaloid, phenolic compound, how you can partition them from organic phase to aqueous phase or common salt phase to the ionic liquid phase, and follow Hofmeister series. We have worked on desulfurization and CO2 absorption, supercapacitor, cyanide sensing, biomass treatment, metal ion extraction, and so on. So to conclude, what I would like to say that you need not to replace your solvent completely, which is impossible or which need extensive study, or any industry cannot change overnight their entire setups. However, you can start looking at adding ionic liquid as an additive or extractant in a smaller quantity, which help you to address the viscosity and address the cost and improve your final results by saving time or by saving chemicals or less damaging environment. This is the Mark Shiflett book, appeared in early this year, February 2020. He has taken up to March 2019 all industries which are not confidential or patent granted. 29 processes are in the pilot scale and 28 are in commercial stage. He also mentioned that there are so many much more in pipeline, but couldn't publish here due to the what you call patenting or the confidentiality. However, in next decade, this number of industrial application of ionic liquid will be more than twice or thrice or so. That's what he's predicting. He's a well-known guy who worked in DuPont, and now after serving in industry, he came back to academia. He's in University of Kansas in USA. So, take-home message: there are millions of ionic liquid possible, and the message to youngsters, if there are anybody, search, research. In research, one can find alternative for anything. If not anything, for many things. Be positive, no negative. Thank you all, and follow this one. What I see that in the next decade, humankind will face significant challenge in energy, environment, water, and food and health related issues. Your research directly or indirectly related to this to solve humankind problems, and you also take care of sustainability, and that's the future. Definitely, chemistry has the big role to play. Thank you all. This is my group and my email. Any questions you can write to here. Thank you very much for the
Yeah.
opportunity.
Thank
And
you
I'm
very much.
sorry for overshooting 5-10 minutes.
Thank you very much, sir. Thanks a lot for such an informative and wonderful session. Sir, as we are running short of time, so I would like to take only one question
No problem.
from P. Senthil Walvan. He wants to know, is it possible to have the synthesized biosolvent from the waste?
Can you repeat? Biosolvents from the waste. You know, people are working on that. There are so many papers. So waste to what you call commodity. Just search in literature, you will find all this sea waste you see even in the lakes and all these things. Depending on your surrounding environment, and people have gone through this rice straw, wheat straw, or all this, even what do you call damaged fruits and vegetables. So people are working on extracting from food waste, bio waste, vegetable waste, fruit waste, or even crop waste, and even sea waste or sea not animals but sea plants. So people are coming up with so many. Since the question is general, my answer is also very general. Yes, it is possible.
Okay. Thanks a lot, sir. Thank you very much, sir, for enlightening us
Thank you.
with your.
And I request organizer, if anybody has a question, please pass through to my email. I will happy to answer.
Sure, sir. Definitely, sir. Thank you very much, sir. Thank you,
Thank
sir.
you.
Now I would like to call upon Ms. Priyanka Roy for further introduce our next speaker, followed by his lecture. Priyanka.
Thank you, Dr. Varuna Mishra. Now, taking forward today's technical session, I would like to introduce our second keynote speaker, Professor S.K. Singh. He's a senior principal scientist at CSIR Central Building Research Institute, Roorkee. He is a professor in Academy of Science and Innovation Research. He is deeply associated with more than 505 sponsors, research and consultancy projects, and published many research papers in SCI Journal International and National conferences. He has supervised several MTech and PhD dissertation. He is a recipient of prestigious Eminent Engineer Award from IEI in the year 2016 and Young Scientist Award from Council of Science and Technology from Government of UP in the year 2000. He is a fellow of Indian Concrete Institute and Institute of Engineering and lifetime member of several organizations like IRC, ISEWE, ISCMS, and so on and so forth. He has also served as a founding coordinator and honorary secretary of Ghaziabad chapter of Indian Concrete Institute from 1997 to 2002. He has several membership in national executive committees and other professional bodies as well. He has widely traveled for his several from the several countries like USA, England, Australia, Greece, South Korea, Sri Lanka, and many more. So on this thought, I would like to invite Professor S.K. Singh to take forward today's event. So you're most welcome, sir.
Thank you. Thank you, Dr. Priyanka. I hope my time is about 45 minutes.
Yes, sir. Yes, sir.
Yeah, I'm clear and loud.
Yes, sir. Yeah, you're
Okay,
clear. Sir.
thank you. Very good morning to all. I'm very thankful to Center of Climate Change and Water Research of Suresh Gyan Bihar University, Jaipur. I'm also very thankful to Dr. Suraj Kumar Singh, who has given me opportunity to present our work at this forum in this 7th Annual International Virtual Convention, Sustainability in Current Scenario, Challenges and Solutions. So with this, because the theme was very attractive, building sustainable society for future, so because you have discussed so many issues from environment to water to climate change to different type of products and other things. So I'm going to present little bit different towards the civil engineering, where a lot of sustainability is required in construction, particularly infrastructure development. So my today's talk is on sustainable construction material for infrastructure development. As we are aware that Sustainability involving three major parts, that is environment, so economic and social. So every construction activities which is been involving with the construction material as well as development of those, so it has a lot of utilization of natural resources and energy. So it should be utilized in such a manner so that it has less impact on our environment. Looking into that, if you look into the sustainable infrastructure, so there is 17 sustainable goals were there, and sustainable development goals were there, where in all sustainable goal, sustainable infrastructure play a vital role. If you look into that SDG goal from 1 to 7, that will be particularly enhances access to basic services, and where that plays important in sustainable infrastructure. If you look into the particular area to promote environment and sustainability, particularly 11 to 15, that plays an important role, where support inclusive growth were 8, 9, 10, and 16 and 17. But where if you talk about the materials or construction, that is basically has an important role on SDG goal on 9, 11, and 13. So,
sorry to interrupt, sir. Sorry to interrupt, sir. Your screen is not visible till now, sir.
Okay.
Yeah, we are not able to see your screen.
It is not visible. Okay, again. Yeah. I have done. Just a minute.
Okay, sir.
Stop. No, it is coming. It is visible.
Sir,
it is a visible.
No, sir.
Hello.
No, sir.
No, sir, it is not yet been shared, sir.
Sir, if you're finding any difficulty, you can mail me. We can share from our end.
Okay, no issues. Just a minute.
No, it's
yeah,
coming.
yeah, coming, sir. It's coming, sir.
Yeah,
Yeah,
It is
yeah.
Now
coming?
it's coming.
Yeah,
Yeah.
Yes, yes, sure. It's visible now, sir.
Sorry.
slide show mode.
Yeah, it is in slide mode. It is visible. Okay.
Yeah.
Yeah, yes, sure,
Yeah,
sir,
yeah.
sure.
Okay.
Please continue, sir.
Sorry,
Please
sorry for that. As we are talking about sustainability on sustainable development goals, which is being internationally acclaimed on 17 SDG, and where sustainable infrastructure play a very important role, I have already discussed. So, what are the challenges before the construction sector? That are conservation of natural resources. That is we are looking for use of alternative materials. That is another is energy conservations, where we look for a energy efficient process, technology and material, and utmost important is the reduction in greenhouse gas emissions. So we have to look into a innovative material as well as the innovative approach. So I'm coming to that whole the system where we should look as a sustainable constructions. We can reduce resource consumptions, reuse of resources, reduce environmental impact of cement productions. So today I will concentrate on how we can minimize our zero cement utilizations into the constructions. Another is the greater use of supplementary cementitious material like fly ash, ground granulated blast furnace slag, and using recycle, reuse of construction and demolitions waste. Service life structures means if we are constructing a building or bridge or highways, should have more service life, so that that can be utilized and we can save our resources. Renewable energies, particularly in cement productions and in process technology, effective control and construction management system, protection of nature, elimination of toxicity, application of life cycle cost analysis, and focusing on quality. So if you look into that, overall energy consumptions is very high, particularly into the Asian country or developing countries. So if you look into the cement productions, about more than 4,000 million tons cement produced, and that was been largest, more than 70% by the China, and next by the India, about 310 million tons per annum. So where, total out of that 70% by China and other, and that 1 ton of cement usually produces about 0.75 ton of carbon dioxide. So if you look into any infrastructure where cement is being used, and we are being affecting our environment and nature much by the carbon emissions. So we have to look at alternative materials, alternative to the cementitious binder, so that we can look into a sustainable constructions. That how this CO2 comes, how it is being generated. It is, calcium carbonate, lime. That limestone is being used to produce majorly cementitious binder or cement. That is being heated more than 1,000 degrees centigrade. If you look into the temperature of clinker productions, it goes from 1450 degrees centigrade to 1500 degrees centigrade. So conversion of calcium carbonate into the calcium oxide and carbon dioxide, and this major amount of carbon dioxide is being going towards to the environment. So the government of India, as well as the different controlling body, is looking how it should be minimized. So people are thinking how we can capture the carbon dioxide, and how should we can look into the alternative materials to the cementitious binder. In this alternative, what will be the benefit? That we can reserve our good quality limestone, clay, sales, which is being used to produce the cementitious binder, and we can reduce the CO2 emissions. And as I have told, because temperature for clinkering of cementitious binder is required from 1400 degrees centigrade to 1500 degrees centigrade, so a lot of energy is being utilized. So also we are talking about the alternative fuel for making this clinkering of the cementitious material. So in that arena, in that area, continuously researchers are working for a different technology or innovative or disruptive technology to look into to substitute this cement clinker. And somewhere we have been able to achieve by utilizing this cement clinker with the industrial byproduct. I have already said it, that was the fly ash and other pozzolanic materials like ground granulated blast furnace slag and other things. Still that quantification of this, what our code, Indian code says, that maximum, if you look into the pozzolanic cement, it can use the 30% of fly ash, or if you can have a composite cement, definitely we can go beyond. So still, can we think about cement-free system or cement-free infrastructure where we can minimize our CO2 emissions as well as our energy consumption? So looking into that, we have started working, or worldwide the people has started working on geopolymeric materials, where utilizing the waste such as fly ash, activating it And without we are making a concrete type of material, as which is known as a geopolymer concrete. And so if you look into that alternative, people has worked on different, but today we are concentrating on this alkali activated binders, which is being coined or named as a geopolymer concrete. And still it is being every alternative binders, because we are used to work towards cementitious material, so it is very easy to handle, easy to place, easy to make a concrete or mortar. So people are used, and so changing with from whatever we are being practicing is a little bit difficult. But yes, that different group are working, and we are making cement free material. So as we have said, the name geopolymer, which is being given as the Devodoids in 1978, but it is nothing but alkali activated that materials, and this is been nothing amorphous inorganic material formed by alkaline activation of a aluminosilicate solid precursor. So that was being the major issue. So usually people ask, what are the differences between a Portland cement as well as a geopolymer? In a Portland cement, different types of calcium oxide based compounds are available, which is being synthesized, and if you add a water, that will be converted into the product which is being binding product, that is known as calcium silicate hydrate, calcium hydroxide, intesides, and others. So measure will be about 60 to 65% is calcium silicate hydrate, and 20 to 25% about calcium hydroxides. And in this whole process, water is required for hydration purposes, where in a geopolymer, it is a polymerization process containing silica alumina, where beyond dissolution of those aluminosilicate, water is released in every chemical process. So if you are aware, you are making any concrete, so every time people say you have to cure with the water for 7 days or 11 days or 14 days, because that should be here, that we don't require any water for curing or other purposes. So geopolymer is the polymerizations, or you can say is inorganic polymerizations, where we are utilizing, and there is no cement, means it is only where we are activating with the alkaline environment with our fly ash or GGBFS, which have been containing aluminosilicate. What will be that? Its uses. It has a wide range of applications, and if you look into that CO2 emissions, it is less than 80% CO2 emissions. Only, that making or some energy consumptions will be there. And here we are utilizing a large scale of fly ash, and low energy consumption is a very high durability material, particularly if you look into the extreme weather conditions. And we are not only conserving our natural resources, but also we are saving energy consumption. So it will be qualifies as a green material or a very sustainable material. Look into that main constituent, aluminosilicate, which is being derived from either fly ash or ground granulated blast furnace. Like GGBFS is nothing but is waste material coming from steel industry, or metacholine, or mine tailing, etc. So mainly if you can have aluminosilicate type of material, and we have alkaline activators, which is nothing but sodium hydroxide and sodium silicate. We have to keep its pH maintaining more than 11.5 for geopolymerization, and adding a normal admixtures for providing a workability, placing, etc. So with these material, we can develop a binders, so which is known as geopolymer. There is no cement, so no carbon dioxide emissions, etc. So if you look into that different bonding or strength or requirement. So silica alumina ratios play a very important role into that binding purposes. So if you keep silica to alumina ratio is 1, so it is good for making building bricks, blocks, and other things. If you are interested to make concrete or high strength material, so you have to keep it 2. And if you are interested to make a fire resistant liner or material, so it should have to keep silica alumina ratio into 3. So these are the listed advantages that I have already told major of thing. But it is, important thing is that it is no water curing is required. If you look into the infrastructure, if you are making a road or pavement or airport or columns or other things where major issues come, strength reductions, because due to the poor curing or poor placing, compaction, etc. So these things can be avoided. And another important thing is that its strength get very good within 1 day, about more than 20 MPa, say 30 MPa. That will be sufficient for a precast construction or application. So usually we require more than 7 days to 10 days for a precast element to transport from factory or place of casting to the place of installation. Here we can do within 1 or 2 days, within 24 or 48 hours we can transport. But this geopolymerization process requires some heat. If you don't provide the heat, we want to make this process on a normal ambient temperature. So we have to utilize some GGBFS to make early reactions, so that some heat will be released, so that can be utilized into the fly ash activation. So I have already discussed that is important. And here one thing is very important, that you have to look the quantified glossy content or amorphous content available into the fly ash or the material to be geopolymerized. So that is the important things. And few influencing parameters for the strength, that is the water to geopolymer solid ratio, alkaline liquid to solid ratio, and molar concentration of activators. If we want to have a more molarity of our alkaline activator, so we will get a better strength, but there will be problem into the handling. So we have to add some admixtures, particularly good for this geopolymer and curing temperature. So if you want to make only fly ash, so you have to give at least 60 degrees centigrade. If you want to make an ambient, so you have to add some GGBS, so that activated in the first phase and converted into the next phase. As we are saying that what were the sustainable effect on this new material, that that we are aware that right now in India coal is being only utilized about 60%. Still 40% is being dumped, and it is a big issue. That still we have started from making embankment to cement to other places, but still more than 40% is being dumped on asphalt. So these fly ash can be utilized into this material. But challenges with the Indian fly ash is reactive material available into the Indian. So because our quality of coal is being poorer and poorer day by day, so reactive material are getting poorer. So if you are going to have a geopolymerization the process, you should know that how much amorphous content is available into the fly ash or other material which is being used for this. I have already said that these are the conventional uses, where being cement, making fly ash brick, reclaiming the mines, different mines, that is for agricultural and for other purposes. But this geopolymerization is going to have a different area. So we are, as a CBRI, continuously working on utilization of fly ash in a different field, from making a bricks to geopolymer concrete to ash pond management to reclamations of ash pond, characterizations, and all those things we have been continuously working and providing services to that all over the country. Uh, but if you look into that, in geopolymer, which has been a cement free material, we have constructed a road in 1917 at CBRI. We have then, because it is sponsored by National Thermal Power, then we constructed a road at Dadri. Then at we have provided a technical know-how for Ramagundam, and for other, for building, for other structural element, precast elements, we have carried out and constructing at CBRI and demonstrating this one. A little bit of chemistry. I'm being a civil engineer basically, but yeah, that aluminosilicates are available in a glassy phase, in a fly ash, that is silicon oxide, alumina, and sodium oxide, which has to be activated through the alkaline atmosphere environment, that is called sodium hydroxide and sodium silicate. And here also sodium silicate is being used as a external silica. And if you give a temperature about 60 degrees centigrade, so it will convert into NaS, that is called sodium aluminosilicate polymer, and that is being a good binding material. It's depend their different structure on silica to alumina ratio. But if we don't want to provide a temperature, or we want to make it ambient temperature, so in this aluminosilicate material can also be utilized as a more calcium oxide based, which is being known as a ground granulated blast furnace slag, which is again a waste material from the industry, that steel industry. So those are the things. If you look into the conceptual model, how this aluminosilicate source may be fly ash, GGBFS, only dissolution of those aluminosilicate required water in aqueous material, that is called sodium hydroxide and sodium silicate with the alkalinity more than 11.5. And after that, in every level, if you know specializations, dilatations, reorganization, and polymerization, and everywhere that water is coming out, and whole the process is again like cement is exothermic process. If you look into that, I'm not going much towards the chemistry part. If you look into those dissolutions, and if your pH will be less, then it will be convert into a crystalline in a geolite. But we have to look into amorphous aluminosilicate gel, so we have to keep minimum of pH more than 11.5 to have a good ion linking and chain formation. So that is a very important parameters which required into whole geopolymerization system. And again, that different, I have already discussed how different content of silicon oxide and alumina which is to be activated should be present, so that it can have. So the role of total reactive oxide ratio present into our material like fly ash or GGBFS, and the molarity and sodium content, they all three play a very important role into the geopolymerization and strength parameter. So fly ash depend. I'm not going to quantifications because time is less. But usually reactive potential of amorphous content in fly ash vary from 35 to 55%, and that plays into this process. So if your high crystalline fly ash is there, so your reactivity will be less and strength and other properties will be poor. So you have to look into that. Our amorphous content should have more and more, so that look into this area. If you look into that, not only in India, all over the world, people are working on geopolymer binder and geopolymer concrete construction. This is first Queensland University GCI building. It is being G+3, has been constructed, and with the all material, with the panels, with column, with that, everything has been made with the geopolymer. It is the first building constructed with the geopolymer, cement free. This is again Melton Library, Melbourne. All those panel, precast panel has been constructed with the activating the fly ash and with the geopolymer. So it is a totally means cement free material has been constructed into that. This is the different type of precast element for if you look into the reinforced earth. Also, we have done on this hume pipes we have made for geopolymer. It is performing very well. We have placed few places into the NTPC colony. This is again one Australian firm at Melbourne. They have given a name, Ecrete brand name, and all those people are working after 2000, and they have made some footpath, etc., and Salmon Street Bridge at Port Melbourne, Australia. Again, you know that some footpath and deck slab has been constructed with the geopolymer materials. So worldwide also people are working, and in this we have also worked working for early 2008 and continuously for 12 years we are working. But what are the challenges into this and what we have carried out at our CBRI? I will show. That challenges is variability in the raw materials, because if your raw material changes from one place to other place, so that you have to identify or quantify that how much reactive materials are available, and because it's new material, new technology, so you have to have give monitoring or quality thing. Also, you know that long-term behavior of geopolymer, it is been available for last 10 to 12 years, but still has not been done, or so it is being, so the people is apprehensive that what is the need of using, because cement is the most available material and can be used. If you look into the cost economics, definitely it is coming at par to the cement ECS. If you go to the market, if you want, if something is cheaper, definitely you're going to have. But if it is of the same cost, so you'll prefer what I'm using, that will be, because you know still making silicate and other things has required a lot of commercializations and acceptance by the client consumers need. We are making guidelines, preparations time to time, and also we are in process participating in Bureau of Indian Standard, so that people can utilize in a large scale. If you look into that CBRI, we have developed ambient as well as heat cured geopolymer, concrete blocks, buildings, lightweight blocks, reinforced, self-compacting, precast element, and we have patent, we have transferred the technology, we have transferred the activators technology, we have demonstrated and published several papers with the structural as well as material parts. These are the geopolymer bricks. What are the beauty? If you look into the fly ash bricks, which has water absorption more than 15%, 20%. People are facing a lot of issues. Strength are coming 5 MPa, 8 MPa, a lot of variability. Where with this geopolymer bricks, with the same shape, same way, we can go up to 28 to 30 MPa, and with the same cost of burnt clay brick. So, and it can be made with the same way with the cement sand mortar or geopolymer mortar. Also, we can utilize. So there is been, these are the hollow blocks. It's look-wise also, because we are geopolymerizing with the fly ash. So look-wise also being as a cementitious color, gray color. So we can do with the blocks. This is right now people are using as a partition wall or filler wall as a aerated autoclave. So we have also worked, and with the density of 800 kg per meter cube, and you can say 0.8 gram per centimeter cube, we have made a cellular autoclave concrete, and that was fantastically, and it's very less connected pores has been observed, better than the cement fly ash based system. So that can be utilized. You know that we have carried out work on tetrapod. This is known as a energy braking system, particularly in a coastal area. So because this geopolymer has a very good resistance to sulfate as well as a chloride, which is big issue with the cement, concrete or other thing into the coastal area, which erode and corrode. So this we have utilized few places in Andhra, and NTPC is promoting. Also, we have done extensive research for structural applications, and we have validated our result with the similar strength concrete made with the ordinary Portland cement, and we found that all the results were comparable. And these you know that few people who are interested, few clients, to make it as a self-compacting. It can flow and won't require any energy during compaction. So we have successfully made this geopolymer self-compacting concrete. Also, we have pumped into our laboratory, and you know that raw materials I have already briefed that we required for making a concrete, like coarse aggregate, fine aggregate, which is known as a sand, and in place of cement, we are using a fly ash, some 10 to 20% are GGBFS, and activators, which is sodium hydroxide and sodium silicate. So these are the view. These are the geopolymer concrete columns, which is behind to our laboratory. We have made these are the hume pipes, geopolymer concrete hume pipes. We have demonstrated. These are the geopolymer planks and joist, precast element for making a building, partial building construction, particularly a roofing elements. We have demonstrated in a successful manner. These are the joist. It is a CBRI old technology. It is made with the cement concrete. We tried with the geopolymer concrete. These are the testing of these planks and joist. If you look into the life cycle cost analysis, that carbon dioxide, if you look particularly in blocks and bricks, that will be less than 50%. In geopolymer, global warming, again, it is say 30% to 20 to 30% will be to that as compared to the OPC. So similarly, if you look into the cumulative energy demand, we have done all those analysis with the CIMA Pro software for sustainable analysis. And this we are the first in country to make a geopolymer concrete roads. Where is the infrastructures and this, and it will be the futuristic day where we are going to make. That if you make a road with the cement concrete, a lot of problems come. That is particularly if you look into the thermal crackings, and if temperature will be high, so a lot of cracks on the surfaces appear. Here into the geopolymer, if temperature increases, its strength increases, and that strength development will be more. So we don't require any water or other things for curing, etc. So we can make roads, particularly airports, etc., with this geopolymer concrete in an efficient and effective manner, utilizing the waste material. You know that a lot of civil engineering, I am not taking different material which is being well established by the Indian standard and other things. So we are utilizing, except in place of cement, we are using activators, slag, and fly ash. These are the, if you can look into, these are the sodium silicate which is been coming into the liquid form, where at site we are making sodium hydroxide because it is coming to the flakes and adding water for the different molarity concentration. So whatever the required. So if you look into that top layer of the concrete into the road, which is known as pavement quality concrete, where we have uses 330 kg of fly ash and 110 kg of GGBFS, ground granulated blast furnace slag. Fine aggregate about 650 kg and coarse aggregate is 1150 kg. And this sodium hydroxide was used of 12 molarity for pavement quality concrete. Below to this peak you see, there was being known as a DLC, what we say separation layer, that is with the only 5 molarity, and we have not used any GGBFS into that, only used fly ash. So that proportioning has given into that. So these are the different steps for construction as civil engineering involved: compaction of the material, subbase, and then DLC. This is the DLC has been made. Then separation layer. Then these are the separation layer. Then we have done a lot of. It was the first in the India, and also making a road first in the world also, because in a full-fledged designed road we have made. And we have done a lot of instrumentation like load sensor, temperature sensor, and other things to know the behavior. And also 2 panels of cement concrete were also cast after to this geopolymer road. And we designed as per Indian Road Congress, and we have done all those material. These are the layings. These are the texturing, because usually if you go to the concrete road, there is a mechanized machines for texturing. We do it by manually putting some steel bar system, and these are the materials being used. Then the grooves etc. has been cut in the same way what has been done into the cement concrete road system. And this is the view. We have put that backing rod which is made with the PU, and filled with the top layer of about 3 to 4 mm with the polysulfide sealant to avoid. This is the road which has been constructed different, and we have carried out instrumentations to know its properties. So I'm not, we have a different other road. I'm not taking to that. We have always doing a lot of chemistry, a lot of chemical analysis. It's hydration process, all those things we do, and look how we can do in a better way. So similar also, that making first road, we have gone for extensive durability study, particularly in accelerated manner for up to 1 year. So, and to look into, and it has performed better than the cement concrete system. There was apprehension with the few people we are using alkaline material, so may it's leach into the soil or ground and may have. Then we have studied different molarity geopolymer system along with the OPC cement concrete, and we found that it was comparable with the same result. So there was no any big issue into the leaching. This is another, because when we have been gathered the information, we modified our mixed proportioning. We gone to M40 grade concrete and successfully carried out all those road constructions into the field. And These are the road constructions what we have done, and if you look into the final view, this is the done into the NTPC Dadri plant, which is the steel yard. And because a lot of heavy load and vehicles are going on, we wanted to study what is happening. It was constructed in 2018 and performing without any surface cracks, etc., is in a very nice manner. After this NTPC, because we have given a technology, we have made a batching plant, modified batching plant, which is for made into that, so that all the concrete could be pumped and laid into the road, particularly in Ramagundam, their factory nearby their in thermal power projects, and this was the constructed road. Nowadays, again, we are making a road into the Netra office, that is a peripheral road of 2.2 kilometer with the geopolymer concrete. So those are the issues. Those are the issues what we have taken and successfully demonstrated. And the basic, a basic thing was that the cost was comparable with the cement concrete. If you look overall cost or cost benefit, it has much more. We have quantified and sustainable aspects. So overall, it will have new era and new things into road constructions or highways construction. A lot of media coverage has been done. We have made also some small Agni. We have accredited for IRC, patent and other things, report, guidelines we have made. Coming to that, we have, I hope it will be 10 to 15 minutes more time. Hello?
Yes, sir. We can have another. Yes, sir.
10 minutes maximum.
Sir,
10
yes,
minutes.
10 minutes.
5 minutes? 10
Yes,
minutes.
sir.
Oh, thank
Yes,
you.
sir.
Thank you very much, because I quickly left because
you already overshooting your time.
Quickly, that Professor Sandeep Singh sir, thank you for being here. So that next thing is that we are working, or my group is working on recycling process for construction and demolitions waste, and continuously we are providing and things. Initially we have worked on coarse aggregate, and presently on working on fine aggregate, which is known as a sand. And that everywhere NGT, Supreme Court, all mining of sand from the river has been banned, and a lot of problems are coming. So we are continuously supporting for utilizing to the construction and demolitions waste. And it has been in India, it's been big, huge amount of construction and demolitions waste are being dumped here and there, and causing blocking, choking of the rivers flow and other things, because so many discussions may have occurred into for last 2 days deliberations. So we have worked and we have made very good process system. To only issue was there in a coarse aggregate, because existing adhered model, and we have a different treatment processes. We can remove those, or we can minimize their effect and utilized, and low cost application, particularly making tiles, block, pavement and other things we have carried out in our if you can see it, in our demonstration park at CBRI has been made with the paving blocks, etc. And nowadays people have started utilizing this one. I have worked on particularly on recycled fine aggregate as well. So we compared with the river Yamuna sand results, and we met and we carried out a different system, so that mixing technique, changing the mixing technique and going with the minimum paste content and that density, maximum density theory we have carried out. Because I am heading to another group, it is called plastic polymer and composite groups, where my group has worked on converting rice husk into the plastic wood, and what we have given name wood without tree. That has been patented, that has been technology has been transferred, and they are making a very good doors, windows, decking materials, and other thing. This has been done, and technology from the CBRI has transferred to the industry. It is being utilized. If you look all the material, and its property has been found better than the wood, good wood, hardwood, if you say, equivalent to teak wood. So, and all the material that farm is making Om Namah Shivaya at Gwalior, they are producing all type of material with this rice husk thing. Also, we have worked on stone waste. I'm not taking much, and we have successfully demonstrated those technology into the field, particularly making tiles and paver blocks, etc. Few industries nearby Udaipur, they have we have transferred the technology. They have established their plant with the help of Rajasthan Pollution Control Board, and they are working. They are being producing and transferring. These are the different, tiles. We have made the waste material, marble waste, as well as kota stones and other things, texture tiles, etc., being used. I'm not going to the lime sign K. Yeah, another material which is been we have worked and continuously working on that to substitute the cement. Also, that laterite soil which is been in Almina Industries nearby. It is again a waste material, and we have modified with the cement and with some enhancer, chemical enhancer, and make clay brick based system. Also, that CBRI worked, not my group, another group, on gypsum, phosphogypsum material, and we developed alpha plaster for phosphogypsum that was transferred to the Naveen Industries and other industries, and they are working, and also on high strength cementitious binder with that. Quickly, I'm because it is a beneficial plant of by Messrs. Naveen Fluoro in Limited Mumbai. They are working and they are producing in that. This is the view of plasters, etc. Also, flue gas desulfurization gypsums. We are working on this. Next area where I am working, my group is working on steel slag. I have said there is a two type of slags coming from steel industry. One is known as iron slag, that is known as a blast furnace slag, because it is a processing of irons. That is when we go for next step, that is known as the steel slag. There is a three type of major steel slag, which is called blast oxygen furnace or Lansdowne slag. Another is called electric arc furnace slag, and third one is a ladle furnace. These are being produced in a huge quantity in our country, about 12 to 16 million tons per annum, and its utilization is only 20%. Government of India, Niti Aayog, continuously watching. They have given us a project, not only to CSIR CBRI, also to CBRI, that Central Road Research Institute and other IITs also, utilization of these steel slag into the large quantities. So we are concentrating, utilize as a electric arc furnace slag and LD slag as a coarse aggregate, and also to ladle furnace slag and LD slag utilizing into the cementitious. So also they have approached to the Ministry of Agriculture and ICAR and IARI for making that acidic soil to alkaline soil, means to as a fertilizer, so that it can have a high calcium oxide and alkalinity with this steel slag can be used. So that we have able to activate those LD slag, because major issue with this one is has a very high crystalline material, more than 52 to 58% crystallinity. So it is not amorphous, so we could not use as a reactive material. And also that calcium oxide and MgO are available in a free state, which provide the expensive material which expand when added with the water or during the chemical reaction, so create internal cracking within the concrete and other system. So or if it will be used as an aggregate with the water, it expand and disintegrate this aggregate itself. So we are able to process, and only yesterday with the ministry that JSW steels we are going to utilize into the road construction, particularly in the concrete and DLC. So these are the different characterizations. So we have a big project, more than 2 crores rupees. 2 crore has given by Ministry of Steel and 1 crore has given by JSW. So we are working on that, and we have identified the root cause, and we are able to demonstrate 30% into the cementitious binder, and that utilizing as a aggregate by processing those steel slag into that. So different processes, because time is less, so I'm being just leaving to that. Also, that this is one big project, also the lime sludge. So our CBRI, my group is working valorizations of different waste material into a useful in a sustainable matter. So because also we can use also bagasse as not I'm going to this one different. So that I am summarizing to this with only sustainable construction is our of the need. So we can look into the sustainable construction utilizing the waste or alternative material. So we should not only the virgin natural material, and that we require to need to modify our Indian codes guidelines. And because I am being involved in making aggregates code, that is a BIS 383. So we have given opportunity to utilize up to 50% steel slag and 20% up to that M30 grade, that is construction and demolition. But we have to provide more and more opportunity to utilize these materials, and promotional scheme government and Niti Aayog, and they should give to those who is going to utilize those material into their constructions. I'm ending with my this talk of Oliver Wendell Holmes, that 100 years after we are gone and forgotten, those who never heard of us will be living with the results of our actions. So our actions should be such that we should look forward a sustainable goal and sustainable constructions material. Thank you very much for giving opportunity for presenting this my work at this forum. Thank you.
Thanks a lot, sir. This is Dr. Varun Mishra, this side from Center for Climate Change and Water Research. So we have received some questions from the participants. I would like to take one or two questions from them. So the first question is from Durva Thapa. He wants to know what is the strength of geopolymer.
Yeah, we have gone up to 80 MPa at our laboratory with the 14 molarity of sodium hydroxide. So it's as your requirement. If you look for less strength, so you can reduce your molarity, and we can go with the more fly ash. So we have been our laboratory gone with the 80 MPa, means 800 kg per centimeter square strength. So usually in the road it is required M40 to M45 grade concrete for national highways specification. If you look into the medium paving block, etc., that required M30, or for heavy loaded that is required M40. So we can go with these type of concrete with the 12 molarity sodium hydroxide with this. So we have gone up to 80 MPa into the laboratory. At a site, 50 MPa. Yeah.
Okay, thank you, sir. The next question is from Jahangir Mohammed. He wants to know how CO2 emission can be from cement production.
Yeah, I have shown my first slide that calcination of that how cement make produce, that is limestone and aluminum is type of soil shale. Those things is being utilized. They will be grinded and they temperature into the big kilns. That temperature goes up to 1500 degrees centigrade. So those limestones which is being used, that has been calcined. So that is calcination of those converting into calcium oxide and carbon dioxide. So that 95% carbon dioxide goes into the atmosphere with this calcination. And if you know that, if you look into the 10 years back, those our cement industries having producing 1 ton of cement by about 1 ton of carbon dioxide, then government continuously pressurizing. So this calcination is affecting, and major things was that we are talking, can we utilize other material as at a grinding level? So we should reduce the heat load as well, means energy consumptions for temperature as well as this one.
Okay. Thanks a lot, sir. So the last question is from Saurabh.
Yeah.
He wants to know that how we can use geopolymer concrete in tension members like beam and slab.
That I have shown most probably, if because time was been 45 minutes, I have shown one beam and I have same grade of M30 grade. We have costed and several beam has been tested. It perform similar way as our cement concrete beam has performed. Not only this, we have done different studies on that, as a flexural member, as a compression member, as a column, means other member. So that perform as a similar way as the cement concrete has performed.
Okay. Thanks a lot, sir. Thanks a lot for your informative lecture on the sustainable development and sustainable management of concrete materials and other things. Sir, now I would like to call upon Ms. Priyanka Roy to introduce our next speaker, followed by his lecture. Thank you. Thanks a lot, sir.
Thank you very much. Thanks to all.
Thank you, Dr. Mishra. Taking forward today's session with the third keynote speaker, I would like to introduce him, Dr. Gopal Krishna, Scientist C, Groundwater Hydrology Division, National Institute of Hydrology, Roorkee. Dr. Gopal Krishna is a scientist at National Institute of Hydrology in Roorkee. He has over 20 years of research experience in many facets of hydrological evolution, surface water, groundwater hydrology, project management, and field investigation. Dr. Krishna has developed skills in hydrogeochemistry, isotope hydrology, and water quality studies. He has published more than 150 research papers in international and national reputed journals, books, book chapters, newsletters, and technical reports. Dr. Gopal Krishna is a fellow member of Society of Earth Sciences, life member of Indian Association of Hydrologists, and member of International Association of Hydrogeologists, Indian Society of Remote Sensing, and American Water Resource Association. Now, on this thought, I would like to invite Dr. Gopal Krishna to take forward today's session. Sir, you are most welcome, sir. Sir, your mic is muted, sir. Please unmute yourself. Sir.
Okay. Yes. Thank you, Ms. Priyanka. Am I audible?
Yes, sir. You're audible, sir.
I'm seeing that screen sharing mode. Where it is screen sharing?
Present now.
Present.
First to go in present now, then you will have two options: entire screen and a window. So you can select anyone from
present now. Yes, present now. Okay.
There are two options, so you can select any one of them.
Oh, okay. Now is it visible?
Yes, sir.
Hello?
Yes, sir. It is visible, sir.
Yes, sir. It's visible, sir.
Yeah, it's visible. Yeah, visible. PowerPoint presentation mode is required. Presentation mode only.
Okay.
Slideshow mode.
Yes.
Yeah, it's
Hello.
fine, sir.
Okay.
Yeah, fine, sir. Fine, sir. Please continue, sir.
So good afternoon, everybody. Uh, so my topic is groundwater dynamics, storage, depletion, management, and climate variability. So somebody from the organizers have posted yesterday on the Facebook about the groundwater issues that was given by some previous speaker. So you all know the groundwater importance. And now the contents of my talk will be the introduction background, why it is so important, and then groundwater development and usage, and then groundwater balance and depletion, and case studies, and demand management initiatives. So when we talk of the water or groundwater, we first see the demand side. What is the demand side and what is the supply side? So if we see, this is the United States Census Bureau records, and it shows that there are shown 10 top countries with the population, higher population. These top populations countries are China, India, US, Indonesia, and Pakistan. These are top 5. So 46% of the world population contributed by these top 5. And other 5, this Nigeria, Brazil, Bangladesh, Russia, and Mexico, these contribute about 11%. So about 57% of the population is from these 10 countries, and rest of the world is 43% of the world population. So in spite of all this, water and sanitation services, if you see, billion still lacks these services, and 3 billion people worldwide lack basic hand washing facilities at home. So if you see how the proportion of population with access to basic and safely managed water, sanitation and hygiene services, you can see here how it is growing, and the demand side is increasing day by day, and can we meet out this demand from the supply side. So if we talk of the total water on earth, so you can see here water is present in the earth either as a sea water or fresh water. So you can see that this large portion is the sea water and only the small portion is the fresh water. And from this fresh water, the component is our ice, groundwater, lakes, rivers, soil moisture. Some water is in the atmosphere or biosphere. So if you see the hydrological cycle, so then sun is the main driver of this hydrological cycle, where water gets evaporated, and when it becomes a vapor form, and it condensed and falls as a precipitation on the earth. So when it falls on the earth, either it goes as a runoff or it percolates down in the groundwater. So it forms a groundwater, or some of the water gets evaporated again, and so its cycles continued. So when we see what is the distribution of this water, then you can see the 97% is saline, that is in the oceans or seawater. Then fresh water is only 3%. So 3% from this 3% water, you can see groundwater is 30%, and the ice caps and glacier is 68.7%. So others is 0.9%, and of the surface water is 0.3%. From this surface water 0.3%, 87 is the lake, river is 2%, and swamp are 11%. So then we show the amount of this groundwater. We can see when we quantify it, you can see here the saline lakes has 60 ppm, oceans have, you can see here 965,000 ppm. So you can, this is 96.5%. So you can see how water is present and how much quantity of it is present. If you see the river, it is only the 2 ppm, 0.002%, and then groundwater, that saline groundwater makes the 0.94%. So groundwater is also not fresh. Some of the groundwater is saline, and some other quality issues also. So then you see the India's water resources in BCM. There are total 4,000 BCM. Out of this 4,000 BCM, 1,999 is the annual water availability, and 1,137 is the utilizable water. So out of this 1,137 utilizable water, surface water is 690 BCM and groundwater is 447 BCM. So there is one Falcon water stress indicator which shows that what should be the water availability, and what is the minimum amount of water which should be available. So if you see, the water stress starts from the 1700 cubic meter per annum to a person. So if it is below that, then it comes to under the category of water deficit or water shortage. And if it is less than 1000, 1000 was less than 1000, then it is called the water scarcity. So similarly, if you see the per capita availability of the water, it is decreasing from the, if you see from 1950 onwards, it is decreasing, and the on the other hand, the demand side it is increasing, and supply side is decreasing. So per capita availability of the water from the world, if you see, it is more than 5000, but in India it is about 15 to 2000 cubic meter per person per year. So if you see the water scenario where we stand, we are on the 133rd in the list of 180 countries in terms of water availability, and 120 in a list of 122 countries in terms of the water quality. So what are these water quality issues in India? If you see, there are some issues like there may be some geogenic problem or some man-made or anthropogenic problem. If you see the arsenic, this is all the geogenic. Then salinity, EC, this may be the geogenic or anthropogenic bone. Then fluoride is also geogenic and anthropogenic bone. Then there's the iron problem, and there is the nitrate problem. So all these the water contaminations issues all over the India. So if we see in the graphically in the form of graph, okay, what is the per capita water availability we can see here, and if you see the other graph, that is the water availability, how it is decreasing, and when it is keep on decreasing. So there are several factors responsible for it. And if we look at the groundwater responses, so we can see here the groundwater is the largest storage of fresh water, accounting for 1/3 to 1/4 groundwater withdrawals, and expanded dramatically in last half of the 20th century. So sustained reductions in the volume of groundwater resulting from human withdrawal or changes in climate have historically been observed as declining groundwater levels, and being a hidden resource in terms of impacts of climate change, it is relatively more complicated than the surface water. So groundwater responds more slowly to the meteorological conditions. So groundwater sustains ecosystems by enabling adaptation to increased variability in rainfall and river discharge. So one more factor that is responsible where we can see the less impact of the climate is the groundwater residence time, which is the ratio of the quantity in storage to the average rate of recharge or discharge. Can be the range from days to 10 of thousands of years. The water present in the groundwater may be the thousands or more than 1,000 years old, or it may be fresh one. So if it is old or more than old, so there may be less impact of the climate variability. So groundwater as a renewable resource, higher rates of depletion raise doubt about its renewability over human time frame and sustainability. Then if you see the sustainability depend on groundwater storage depletion is negligible, assessed on the factors surface water flows, land subsidence, water quality, socio-economic impacts. So there is need of predictive understanding which offers a long view scientific basis for policymakers and water managers to make sound and defensible policy decisions. So global groundwater use in 2010, it was about 982 cubic kilometer per annum, and India has a 250 cubic kilometers, about next to about the 1/4 of the global groundwater use. So third largest users combined are China, United States, and with about 110 cubic kilometer per annum. So this large and expanding use of groundwater is the primary driving force for concerns about the groundwater depletion and sustainability of the groundwater pumping. So if you see the groundwater balance, equation, then we can see here the change in storage. This is the change in volume over the change in certain period. You can see the rate is the recharge in the undisturbed condition and recharge over a period of time. So when we subtract the discharge rate from here and total discharge and the global rate of pumping, then we find the change in storage. So if we see these are two balances. This is under natural conditions. When recharge is equal to the discharge, means no disturb, nothing is there. So it is natural condition, it is perfectly balanced. But when we are inducing some stress, some stress is induced. Means pumping is done, we are changing the storage, we are leading to the change in the discharge. The discharge will be changed sometime. When higher the pumping, discharge may reduce, or there may be some capture, so recharge will be introduced due to that stress. So there is surely some stress will change all these parts, aquifer properties. So, but what effects the groundwater depletion and storage is having? That may be economic and societal benefits, because the water is used for the domestic purposes and the agriculture purpose and the industrial sectors. So if you see the declining water levels, these are reduced well yields, high costs, energy for deeper exploration, and affecting the neighboring aquifers. And the land subsidence also. Land subsidence is it is the chloroelastic effects and consequences. Clay mineral structure itself realigns in a more compact and irreversible manner. And there are the other impact also, like sea level rise, because there is some pressure, some stress is there, that also the global groundwater depletion may have contributed to 0.3 to 0.4 mm per year to sea level rise. So these are the some effects. So if we see the groundwater storage, groundwater recovery and climate experiment has enabled large scale satellite monitoring of changes in total terrestrial water storage globally. So GRACE satellite sense the movement of total terrestrial water mass derived from both natural and anthropogenic influences globally. So changes in groundwater, earlier it was said that the GRACE data is not giving the exact details of the groundwater storage. So then the other factors which have been taken into the account, those were the change in the soil moisture storage and the soil water storage and the snow water storage. So then total water storage, when we subtract all these components, then it's a global water storage. So if we see the recent changes in groundwater storage, 2002 to 2016, in 37 of the world large aquifer system. Aquifer is the place where this water is stored, groundwater is stored, is called aquifer. This aquifer may be confined or these may be unconfined. So if you see that these 37 aquifers, so we can see here it's as per the database of the worldwide hydrogeological mapping and assessment program. You can see here long-term trends in GRACE derived groundwater storage of this large aquifer system explained by the linear trend fitting. This comes into the linear trend fitting and this is a non-linear. And these gray shades and other shades, this give the aridity index. So our India is comes in the this shade, semi-arid regions are there and some arid regions are also there in India, and there is the humid regions are also. So India has all these properties, and you can see here it is the trend of the changing this is somewhat non-linear in the Gangetic in India. There are two basins. One is Indus basin and one is the Ganga Brahmaputra basin, Ganges basin and Brahmaputra basin. So it is called a Indo-Gangetic basin. So then if you see, because we cannot see the groundwater storage or depletion in terms of the annual or other, there are some seasonal changes are also. So seasonal changes, like in India, there is the monsoon effects are very you can it get visible. So if you see, there are seasonal effects are there, and we can clearly see these are also in the other parts also, because it is not a comprehensive that. So there the seasonal and the trend and then the remainder. So this is our Indian and South Asian part. So then the time series analysis, because the groundwater depletion does not occur at once, because if we extract the water from the long time back, we are extracting this water, so there is certainly the depletion of the groundwater. It is for the Indus and Ganga Brahmaputra basin, how the water is declining, and the main declining have occurred in the last 4 and 5 decades. So if we see the global and regional trends in surface water and groundwater use, we can see here in 1900, the global population was less than 1.7 billion and groundwater withdrawal was just 500 cubic kilometer per annum. But currently it is exceeding the 7 billion, that is the 4 times almost, and 6 times increase in the groundwater withdrawal. So if the groundwater withdrawal is certainly increasing over that period of time, and the agriculture is the dominant water user. It is ranging at different percentage. Somewhere it is 70, or somewhere it is ranging up to it is going up to the 90% also. So we can see here the change in groundwater and the surface water. We can see here the surface water is decreasing and the groundwater use is increasing, or in all the major basins of the world, and including our Indus and Ganges basin. So groundwater use and irrigation. So why this? Because the irrigation is the largest consumer of the groundwater. So we see here how the groundwater increase is over the whole world. So we find here the percentage of area equipped for irrigation, irrigated with groundwater per statistical unit, and top irrigated grid in the global map for in irrigation area. Here we can see the groundwater usage for irrigation in US and India. It is continuously increasing in Indian part. So the slide is not changing. There are some. So can you see the slide? Hello?
Yes,
Yes,
Hello?
sir.
Okay.
Yes, sir.
So this is the characteristics of the global water cycle. So if you see these characteristics, first is the flux. Flux is the how much it is the input or contribution, because in groundwater balance or other things, it is the inflow or outflow, right? Input or output. So groundwater flux we see here 12,600 cubic meter per annum. But what are the groundwater withdrawal? I have seen, I have shown you that is about 1,000 cubic kilometer per annum. But if so much of flux is there, then why there is a depletion? Because it is the regional trend. In certain regions of the world, the groundwater depletion is more, and in certain region it is not that much used. So if you see the total storage is this much, and residence time up to the 1400 years. So see the surface water flux, then we can see here 44,700 cubic kilometer per annum out of this 0.1 million cubic kilometer. And then soil water is also, it is the plant usable water, which is the use for the crop growth. So you can see here 116,000 cubic kilometer. So if you see the atmospheric water, it is also the significant contribution. So now I am showing you how the regional trends are varying, and so the reports by the various researchers are different, because in every region the global groundwater depletion rates are different, and so there may be the different estimations from all the researchers all over the world. So if you see the groundwater abstraction and depletion, we can clearly see here, this is the groundwater abstraction, which is increasing from 2,312 cubic meter per annum from 1960 to 734 cubic kilometer per annum in 2000. It's subsequently leading to the resulting in the higher this groundwater depletion, which is also increasing from 126 cubic kilometer to 283 cubic kilometer per annum. And similarly, because it is all happening due to the rise in the global groundwater demand, and this global groundwater demand is increasing as a result of increase in population, increase in your agricultural activity, and the less recharge, leading to the groundwater depletion also. So if you see the global groundwater depletion and potential for changes in groundwater recharge in areas of groundwater depletion, so you can see here the mountains, how the groundwater, these black mountains will show you the groundwater depletion rates. So potential of, so these are small mountains are everywhere, but in this part, in Indian part, it is very high. So in Asia, the groundwater extraction is very high. So then we see the major aquifers of the world. So if you see, these are the major aquifers of the world, and this is the Indo-Gangetic basin. So I will showing you some case study, one of the case study which we have done in the Indo-Gangetic basin, and other the most extracted, most prominent part, that is in Punjab also. Those two case studies I will show you. So if you see the aquifer of the India, then we can see the alluvium is the largest. Then there may be some basalt portion, some gneiss granite infusion, lateritic also. So all these type of the formations are there. So if you see the groundwater development, so groundwater development, this is the data taken from the Central Groundwater Board, which is the groundwater, that is the major groundwater authority also. And then we see that they work on the blocks. The assessment unit is blocks, and out of total 6,881 blocks, they are overexploited. What is the overexploited? Overexploited is that when the availability of the groundwater is more than, availability is less than the groundwater draft. So groundwater draft is increasing over availability. The ratio is certainly crossing the more over 100%. And if this is the overexploited, the 1,186 blocks are over. These red are really alarming, and the dark zones where the groundwater exploitation is very high, and it is in the mainly focused in the northwest region of India. And if we see, then this 60% of the assessment in Delhi, Punjab, Haryana, and Rajasthan are either in overexploited or in the critical block. So there are safe only 4,310 blocks. And the groundwater rate of groundwater decline, it is different for all the places. It may be 0 to 2 meter in 42.7% of the area, 2.4 meter in 2 to 4 meter in 11.5% of the blocks, and more than 4 meter. It is also more than 4 meter in 7.2% of the area. So if you see the groundwater levels, there are two type of, if we assess the groundwater levels is from the above the ground, from the ground we measure the groundwater levels, it is below the groundwater level. So if we see from the mean sea level, then it is the water table. So groundwater level below, if you see the water levels, we can see here, these are the dark here, more than 40 meter. So groundwater is going deep and deep, because in search of water, we are digging it very deep. So we can see here clearly how the water levels are going down in the northwest part. So effects about the India, that 85% of the rural and more than 50% of the urban drinking water supply is groundwater, responsible for more than 80% of net irrigation command added in the last 4 decades, and more than 60% of the irrigation requirements. If we see the extension of substantial quantum of this groundwater, the largest user of the groundwater in the world is the India. The largest user is the agriculture. It is about 90%, followed by domestic and industrial area, which is about 10 to or more than something. It depends on the area wise also. Then extraction is often without due regard to the aquifer capacities. We don't see what is the capacity of this aquifer. We go on extracting this, and we go for the deeper. Then it's posing the stress on aquifer, and then if there is stress, what it will cause? It will lead to the overexploitation, which I told you, draft is increasing over the availability. And then the groundwater contamination. Groundwater contamination also, there may be natural or anthropogenic. Natural means they are through the minerals, naturally they are coming here, and anthropogenic from the man-made activities like the irrigation of fertilizers or some other activities or industrial pollutants. So these are all the contamination from the anthropogenic sources or the micropollutants. These are from the. Then the climate change effects. The climate change effects are also the natural, or some climate change is triggered, but there are so many lectures in the climate change, but it is not that prominent in the groundwater as in the surface water, because surface water is more vulnerable to the climate change effects than the groundwater, because the groundwater is a very old something. So that effect is not there, but effect is maybe there, that I will show you in the coming slides. So I am showing you the two case studies. One of the case study in which our institute I was involved, that is in the Indo-Gangetic basin. In this case study, we have first developed the hydrogeological typologies of the Indo-Gangetic basin alluvial aquifer. It is a large team from all over the world. It was from UK, US, and Bangladesh, Nepal, and this is I am also in this team. So we developed the hydrological typologies. But we have seen here over the whole Indo-Gangetic basin, we see the distribution of rainfall, how it is varying. This is the semi-arid to the arid region, where the rainfall is less than 250 mm. It is slightly increasing in the mid portion of this Gangetic basin from up to the 1000 mm per annum, and then certainly it is increasing when we go to the eastern side or going to the towards Bay of Bengal. It is very high. And then if you see the sedimentology, sedimentology is the thing, because most of the alluvium or sediments, those are redistributed through the various tributaries, rivers to these plains. So these may be distributed over a long period of time, or these may be recent also. So if you see the Pleistocene is more than 2 million to about 11,000 years ago, and then there are Holocene also, which are less than the 10,000 years. So these are the Holocene segments. So this is the sedimentology of the Gangetic basin. Then we saw the aquifer properties. Aquifer, as I told you, it is the largest. These are the storage for the groundwater. And if you see because we have groundwater is available when there is the high conductivity and high storageability is there. So if we see the aquifer properties, then we can see the conductivity is very high in this region, and storageability is also very good in this aquarium condition. The permeability, how the what is the ability, how much it can be transmitted, so it can also, it is very high permeability. So if you see the specific yield is the amount of water that can be taken in the change in the unit height of the water. So it is ranging from 0.1 to the 0.2 in the entire area, and in this area it is about 0.12 in the northwestern region of the India. So if you see the groundwater depletion, then as I told you, it is the varying from the 0.05 to the 0.75 meter, more than 0.75 meter. It is in this region, it is groundwater. And that the groundwater issues are other than the quality issues, the groundwater salinity. If you see the salinity is the thing, it is the dissolution of the salt, and which makes the water unusable for the purpose for the drinking or irrigation purposes. So if you see as per the guidelines of the WHO, up to the 1000 ppm TDS we can use it, but above that we cannot use that. So here the salinity, higher salinity is in pockets. It is not stretching throughout the entire area. So it is in the stretches. So this is the distribution of salinity. This is near the ocean, where the ocean sea salinity is there. The salinity may be due to either due to your natural regions or primary salinity, or it may be due to the other, it may be the inland also or coastal salinity also. So what is the mechanism of salinity from this? We can see here the salts are dissolved in the water. The water gets evaporated and the salts come to the surface. And again, if there is precipitation, these salts are leached down to the groundwater and makes the groundwater saline. So the second problem is the arsenic. The arsenic is also very hazardous in this Indo-Gangetic basin. This is also one of the groundwater contaminant, and the main reason is the natural. It is come through the sediments. When we go deeper, or there are various factor or various theories ki how the arsenic is coming to the groundwater. So we can see here arsenic problem is not that much higher in this region as in the eastern or the central part of the Gangetic basin. So this was a paper we published in the Nature that is on the groundwater quality and depletion in the Indo-Gangetic basin, mapped from the in situ observations, where we have taken about more than 3000 wells. We have taken the data from there, and it has an estimated that the total volume of groundwater to be about 30,000 cubic kilometer, and about 20 times the combined annual flow in Ganges, Indus and Brahmaputra. However, as estimated, 23% of this is saline and 37% affected by the arsenic. So 60% of the water is the problematic. So these are some of the data which I have also shown. So managing the groundwater irrigation, these typologies were laid over one, then to found out for the integrated management solutions. So this we have proposed how the salinity and all this varying in the entire area. So this is the main focused area where the groundwater depletion was very high. So inferences of this study was that population growth and porosity increases demand for food, but is there enough water and energy to sustain this? This was one of the questions. Then more than 80% of the water affected in northwest India is used for irrigation purposes. The availability of cheap water has been a springboard for agriculture. Like we subsidize it or something like this. It is easily available. There was no regulations when we go for the tube wells or hand pumps. The water is being extracted, and the water in many areas becoming contaminated. Now we have also observed some contaminations of fluoride, arsenic and uranium, or affected by the salinization. So increasing the irrigation efficiency is not necessarily the answer for this. So these were some of the influences. This is second case study, because Punjab is also it is the bread basket of the India, and there also the water is used for irrigation. So a lot of groundwater structures are there, which was about something like about 1.9 lakhs in 1990, increased to the 14 lakhs today. So the groundwater structures are increasing in Punjab. So this was the work done by us in Punjab, which we have the intensive groundwater exploitation in Punjab for evaluation of resource and quality trends. And then one paper we have just we measure the ages of the groundwater, how much the age of the groundwater in these profiles, and age depth profiles we measured, and for the Northwest India. And then we also studied these arsenic, uranium, and other fluoride, nitrate problems through this groundwater quality in alluvial aquifer system Northwest India, new evidence of the extent of anthropogenic and geogenic contamination. So these were the work done by us in Punjab. So if we see the Punjab, which is comprising 1.5% area of the country, so and contributing 40 to 50% of rice and 60 to 65% of wheat to the central pool since last 3 decades. And three perennial rivers in Punjab. This is your Beas, this is your Satluj, and then one river is going through and entering the Haryana. This is Ghaggar, and this is Ravi. The Ghaggar river is seasonal, mainly in the monsoon seasons. So water potential of all these rivers it is 14.54 million acre feet, managed through well organized canal irrigation system. But still it is not able to meet the demand of water for irrigation in agriculture, which increases the pressure on groundwater resources. So if you see the land cover of Rabi season, I am showing, we have the Kharif season map also, but I am showing Rabi season because we have done some studies on the climate variability or rainfall trend analysis, the Rabi season. So that's why I am showing you. So if you see obviously agriculture is the dominant here in the Rabi season, and the other fallow lands are all these there. And if you see the surface elevation, it is varying from 650 meters near the Shivalik region. It is the north and northeast part of this Punjab, where it is Himachal Pradesh and the Jammu Kashmir are located. And then we go down, it becomes flattening, and it becomes flat lands in their central part of the Punjab, and it becomes when we go towards the Rajasthan. This is the Rajasthan area, and this is the Pakistan area, and here we can see it is the desertic and undulating, but is gradually been becoming level with the extension of cultivation and irrigation. So this was the surface elevation, and if we see the rainfall of Punjab, it was about 800 to 1200 meter in Shivalik Hills. In this region, the rainfall is also very high, and in this region, the rainfall is 400 to 800 mm, and this rainfall is very less because it is near to the desert region of the Rajasthan region. And then Punjab State Agriculture-Based Economy, the total water requirement is about 62 BCM. And so surface water is 17.5 BCM, and replenishing groundwater source is 20. Still there is a deficit source, which is they try to meet through the outer. There are some rain-fed areas also in this Kandi belt, so they are dependent on the rains. But there is now Kandi Canal is coming, so it will solve some problem for the this area. Then if we see the stage of groundwater, as I told you, we categorize the groundwater into the various blocks. Where there's the overexploited blocks are those where the groundwater draft is more than the groundwater availability. So here we can see the stage of groundwater is more than 100% in all the districts except the 4 districts here: Pathankot, Muktsar, Fazilka, and Bhatinda. These districts are very, because in Muktsar, Fazilka, and Bhatinda, why there is less groundwater usage? Because there are people are using canal water in this area, and so there's the problem of water logging is also emerging in these 3 districts. And Pathankot and Gurdaspur area is also there. Some water water is still not that much used. So there is also not an issue of the groundwater depletion. So if you see the categorization of blocks in Punjab, so these were 1984. There are very less blocks. Less means about 50 blocks. Only 50 blocks in the overexploited category, but these are more than 100. These in 20 years, 2 decade times, because this was an era of the green revolution and post green revolution era also. So a lot of structures were developed in the search of more crop, and you can see here how the groundwater is being used. And this is the map of Punjab, which is completely red. This red portion is the overexploited blocks, and these are blank. These are the safe blocks only, and these blocks are waterlogging problem is emerging in these areas because there is a lot of canal water they are using, and salinity issue also, because one issue is the salinity of that's why they are not using the groundwater that much. So this is the thing. Then the groundwater level difference, if we see how the contours are varying. We can see here how these contours are going towards the movement of the water towards this side, because the water extraction is more in this belt and the water is moving to this area, means there is ingression, and this water is not good. I told you this water is saline water. So there is definitely salinity ingression in central Punjab from the southwest Punjab. I am doing the study referred to me by the Punjab government. There are two studies, one by the Department of Agriculture and one by the Punjab State Farmers Commission, where we are identifying the zones where the salinity ingression is taking place. So these are the some serious issues in the groundwater. So these are the how the groundwater curves are varying in whole over the Punjab. It is, so I told you it is not the like a comprehensive thing. We can say the whole state is the decline. It is the place to place there is the variation. If you see the time series data of the Punjab for more than 20 years, we can see here in Jalandhar district the water level is highly depleting. There is depletion in which is not that much high in other districts, and there is no depletion in some areas. So it is not the same. So if we see the rainfall, so rainfall is the major contributor to the groundwater, or it is the major contributor not only to groundwater, to the rivers also, because rivers and canals which are going in all the Punjab, water is being contributed from the rainfall only. So if we come to the rainfall, we see here the rainfall is majorly occurring 80% during the July to September. So it is for about the 119-year data, which is showing that the rainfall is 80% in these months. Then if we see the rainfall trend analysis, we done the rainfall trend analysis, and we found that the increasing rainfall trends in annual monsoon, pre-monsoon and post-monsoon seasons, and winter rainfall is found decreasing in 11 districts, and the rainfall is likely to increase in Punjab. But rainfall has a rising trend at some southwest Punjab, namely Bathinda, Moga, which currently receive low rainfall. So these are some of the trends of the rainfall, but it is decreasing in the winter season. So that's why I have shown you a Rabi season land use, because it may be the cause of concern for the irrigating these areas, because if there will be less rainfall in winters, more of the groundwater will be used in this time. So then we conclude we have done some recharge studies also through rainfall infiltration method, which is the simplified. We see the water level, we see the specific yield and the area and the groundwater draft. Then we compute the groundwater recharge, and the second method is given by the Q method, where we see some equation for the semi-arid regions. Using this equation, we found the groundwater recharge. So here we can see the groundwater recharge, how is varying from the rainfall. If the rainfall is decreasing by the 20%, the recharge is decreasing by the 60 to 65%. So recharge is decreasing by it may be some other region for the decrease in rainfall, because the more of the concretization will be there, less area for the recharge we are finding. But rainfall is also one of the reason, because rainfall is the main recharging. So there is surely definitely there is a change in recharge patterns, and the inferences of this work was that the analysis of the mean annual recharge based on the 1019-year data shows changes in recharge. Reduction in winter rainfall will result in exploitation of groundwater for irrigating the Rabi crops. In general, a decline in groundwater recharge and resources would be expected over the semi-arid such as Punjab. There is a need for alternative groundwater management practices to control impacts, particularly in situation of groundwater dependency. Artificial groundwater recharge may become a useful technology under these conditions. So I am showing you all these inferences and all these things, but this is different in different regions, not in the Punjab. This is the UP region. UP region, this is for UP. You see the groundwater decline is 17 centimeter per annum at post-monsoon decline, and it is also decline from the district to district. If you see the western UP in the major portion, then all the blocks, it is decreasing, but the rate of decline here is 17 centimeter. Here is a 29 centimeter. Here is the post-monsoon decline 30 centimeter, 13 centimeter. Here 20 centimeter. So these are declining trends are different for different places and different places. So what should be the management? So different schemes are there. If you see the groundwater management issues and challenges, because every area has its own issue. So over exploitation is Rajasthan, Haryana, Delhi, Punjab. These 4 states has overexploitation. Then suboptimal utilization, because there are ample groundwater, but suboptimal utilization. There's a Bihar, West Bengal, Assam, and other northeastern states where there is a lot of water is there. Then high dependence, western arid region, where high dependence, arid region, desertic conditions, there is no water, drought conditions, low yields, and sustainability in hard rock areas, because there is no particular aquifer systems are not well developed in the hard rock areas. So there are something low yields and sustainability. Water logging and salinity in Kerala, as I shown you in the southwest Punjab, what is happening? People are using the canal areas, and there are some. These are also leading to water logging and salinity. And if you see, I told you the salinity is also of two types. One is the inland salinity, and other is the coastal salinity. So in the coastal, there is saline water ingress, and coastal saline water ingression is not only in the coastal areas but in the inland area, which I am doing in the 2 studies, one in the Haryana and one in the Punjab, what is World Bank funded, and when I told you this from the World Punjab government funded. Next is the groundwater contamination. Groundwater contamination is also in the geogenic and anthropogenic factors I told you, either natural or the man-made. So these are some of the key issues of groundwater management when we freeze, and there are some challenges also. But there are some groundwater governance initiatives by the government organization, and there may be some NGOs. We are doing very active and very good job for the in this field. So groundwater is not directly beneficial. There are some collateral beneficial or some of the schemes by the government, like central. This is Mahatma Gandhi. It is employment guarantee use NRM component, where the employment is given to the rural people, and they dig the water conservation structures, and some structures they check the this surface water runoff and other things to conserve the water. So this is also very good scheme. Then Pradhan Mantri Krishi Sinchai Yojana, more crop per drop, about 143 hectare of the land they have to. They have means 45% of the total area which is brought under the irrigation. The Pradhan Mantri Krishi Sinchai Yojana is mainly aimed to provide irrigation through the all irrigated area or the cropping area. So 45% has been already done, and there is more crop per drop is for the using the crop efficiency. Then one more scheme is there, that is the Deen Dayal Upadhyay Gram Jyoti Yojana. In this Yojana, what are they doing? They are providing electricity to the every household. In the villages, they are electrifying it. They are providing all these facilities, which was earlier also called the Rajiv Gandhi electrification scheme, something like this. And then the PM Kisan Urja Suraksha Evam Utthan Mahabhiyan, because it is not necessary you give the hydropower through the hydropower other. This is based on the solar power. So if we get the solar power in all the villages also, that is also Suraksha Evam Utthan Mahabhiyan. And then the National Rural Drinking Water Program, it is to provide the drinking water to the all villages. So it is also a very good program. So if we will provide all the drinking water to all villages, so there will be less dependency on the groundwater. Then Jal Shakti Abhiyan, I was also the part of it. I was looking the this Telangana state. And this was a very good initiative by the government of our Ministry of Jal Shakti, Government of India. So I was in the Vanaparthi district of the Telangana, where Jal Shakti Abhiyan was. There were 5 interventions. We are focusing mainly the 5 interventions. What those interventions were like? First was the to conserve the water by making the recharge structures or rainwater harvesting. Rainwater harvesting was also one of the. Then reuse of the water was also very important. There were some magic soap pits they were developing there in Telangana. And then there was the one more thing, the intensive cultivation. If we do the cultivation, because the plant roots, they also check the water and the soil erosion also, because the soil also they bind it very well. And then the Jal Jeevan Mission. Jal Jeevan Mission is also the Ministry of Jal Shakti Mission, and where they are providing tap to the every household. It's a very good mission, and so making the water available to all. Then if we come, this was the central scheme. If we come to the state, then Mukhya Mantri Jal Swavalamban Yojana. It is in the Rajasthan, where they are providing the water, and it is also based on the water conservation. Then Jal Yukt Shivir Abhiyan in Maharashtra. In Maharashtra, most of the places are drought.
Sorry to interfere. Sorry to interfere, sir. We are running out of time, sir. Sir, we are running out of time.
But I'm just finishing in 2 minutes. Okay, 2 or 3 minutes. Then Sujalam Sufalam Jal Abhiyan in Gujarat is also focusing on the Jal conservation. Then Mission Kakati in Telangana, Niru Chetu, Andhra Pradesh. These are also water. Jal Dharo, Jal Bharo in West Bengal. It's also on the west, rainwater harvesting. And then in Punjab, what has, then they banned the early sowing of the paddy. Then Khet Talab, they are digging the talab in the whole state. That is also conserving the water and recharging the groundwater. Then Pani Bachao Paisa in the power. If you save the power, you will get the money, and you will get the other incentives also, the other schemes. And then there is the demand management. If you see the from the NGOs, they are also doing some very good work, like the Hivde Bazaar and Ralegaon Siddhi. Hivde Bazaar by Dr. Popat Pawar, then Ralegaon Siddhi by the Anna Hazare ji. Then Marvi Rajasthan also, they are doing some good work on water conservation. Lapuria NGO Lakshman Singh, they are doing also very good. Beat Jalna Satara district of Maharashtra, these are also drought prone area. Then these driven are mostly personality driven. And if you see, there is one in Maharashtra, the Pani Foundation of the Amir Khan also. Then absence of the government support restricts groundwater management, and these are on the small levels or the village levels. So scaling up remains an issue if to how to disseminate their technologies to other part and what they are doing, how they are managing. So this I will finish with this because the water I am also running out of time. So I want to acknowledge the funding received from this case study from the BGS, British Geological Survey Department for International Development, and Punjab State Farmers and Farmers Commission for funding the study. And I would like to thank our director at National Institute of Hydrology, Chairman Punjab State Farmer Commission, Global Groundwater Researchers, and CGWB, and organizer of this. Particularly, I want to mention the name of Dr. Suraj Kumar Singh, who has played a key role for inviting me to this forum. I am really grateful to all these people. So thank you very much. If you have any questions, please go ahead with this.
Thanks a lot. Thanks a lot, sir. This is Dr. Varun this side from Center for Climate Change and Water Research. We have received several questions, but as we are running short of time, so I would like to take only one or two questions.
Okay.
So the first question is from Khadija. The question is, what is the most efficient way to restore the groundwater in less precipitated area?
In less precipitated area are like your arid areas or desertic areas, or just I told you or Rajasthan areas or arid where we have, because there the rainfall is less than 400 or even sometimes 250 mm water. So you have to conserve that water. Only the rainfall you have to conserve the rainfall only through the rainwater harvesting structures. There are some local schemes in Rajasthan. They have some local way, like the Chauka system or the other systems. It varies from state to the state, so they can conserve the water through this way.
Okay, thanks a lot, sir. So next question is from Amrish. He wants to know what is the region of the salinity in Haryana, Punjab region, as it is very far from the coastal regions.
Okay. Yes. There are very different theories for the salinity in this region. As I told you, in the canal command area, one of the region is for the salinity. As in, I told you, southwest Punjab. I'm doing the studies in Punjab and Haryana. In Punjab, in southwest Punjab, people are using the canal water. So they are not using the groundwater. So what happens? The groundwater level rises up, and when the water level rises up, there is evaporation. The water will be evaporated, and the salts will be deposited and the salts will the salinity will continuously increase. And the second, in Mewat region, that is some different theories are there. One theory is that some long time back there was some Tethys Sea was there, and the water and salinity from that time it is trapped in the groundwater structures there below that, and then that is coming up in the Nagina block of the Mewat district. The salinity is very high, and that is mainly due to the geogenic regions. There is not a canal component. That is the second region of this salinity. So this is the salinity is increasing.
Thanks a lot, sir. Thank you very much for such an enlightening lecture on the groundwater resource management and planning. It was really very wonderful lecture on groundwater management and planning, sir. Thank you very much, sir. So now I would like to call upon Ms. Priyanka Roy to introduce our next speaker, followed by his lecture. Priyanka, thank you very much, sir.
Thank you, Dr. Varun and Mishra. We taking forward this technical session, I would like to introduce our fourth keynote speaker, Dr. Ritesh Arya. He is the Director of International Sustainable Energy Organization, Geneva. Uh, Dr. Arya is a geologist from Punjab University, Chandigarh. He is a Guinness Book World Record winner and a member of WG National Institute of Hydrology in Roorkee. He was appointed as director, geothermal section of International Sustainable Energy Organization affiliated with United Nations. He blended modern technology and traditional hydrogeological wisdom to prepare conceptual model to explain occurrence and movement of groundwater resource in Himalayas, which were earlier considered to thought to be devoid of it. And then this was presented in the international forum, that is Geological Congress in China. Through his first project sponsored by Water Aid United Kingdom, he succeeded in providing water to Tibetans who had fled Tibetan region due to the Chinese aggression in 1959 and settled in Ladakh. He pioneered in groundwater solution for civil and army in Siachen, Kargil, Leh, and other remote inaccessible areas in Himalayas. India today has rightly called him the incredible waterman. Dr. Arya developed concepts of Agni Ayodhya Gara, lava energy, geocognition, a concept of producing GIGA, watt of green, clean, and safe and free sustainable energy for all. Guardian judged Agni Gara as among the top most innovative innovation in the world for featuring the energy summit at Abu Dhabi. Dr. Arya geological findings of the first time significantly showed the climate change and natural cyclic process, but pollution is made by the man and needs to be controlled using better technologies in nowadays. So on this note, I would like to invite Dr. Ritesh Arya to take forward this session. Ritesh Arya, sir. So please present. Yes.
नमस्कार। आज का मेरा विषय आपके सामने है ग्लोबल वार्मिंग, एंजॉय इट। प्रेजेंटेशन शुरू करने से पहले मैं चाहता हूं कि आप छोटी सी 10 सेकंड की एक छोटी सी
Pranay sir, there is no voice coming. This is actually a video sent by Dr. Arya. So that has been played. Pranay sir, there is no voice coming.
Hello, as Dr. Arya is stationed in Leh and Ladakh, and the internet connectivity is too poor, that's why he has recorded the lecture and he has sent the video. Pranay, don't do anything extra. When you started the video, it was perfectly right. So you can restart the same video again and don't do something extra.
आज का मेरा विषय आपके सामने है ग्लोबल वार्मिंग, एंजॉय इट। प्रेजेंटेशन शुरू करने से पहले मैं चाहता हूं कि आप छोटी सी 10 सेकंड की एक छोटी सी तो बेसिकली ग्लोबल वार्मिंग है क्या? अगर हम इस स्लाइड को देखें, जो भी फिल्म दिखाई थी मैंने उसको देखें, तो उसमें एक स्ट्रीम फ्रोजन है और एक में पानी बह रहा है। यही एक थीम को लेके मैं आगे अपनी प्रेजेंटेशन बढ़ाता हूँ और इसके इस फिल्म के जरिए मैं अपनी बात को रखूंगा। जब भी हम ग्लोबल वार्मिंग के बारे में सुनते हैं तो एकदम ख्याल आता है अंटार्कटिका का, आर्कटिक का और वो बर्फ का जो उसमें पड़ी हुई है, जमी हुई है इतने सालों से। दूसरी बात आती है कि ग्लोबल वार्मिंग के कारण जो ग्लेशियर्स हैं वो मेल्ट हो गए और जो पोलर बियर्स हैं वो बेचारे बहुत दुविधा से एक जगह से दूसरी जगह में जा रहे हैं और उनकी अस्तित्व ही खतरे में आ गया है, क्योंकि सारी की सारी एक समय आएगा जब वो सारा का सारा बर्फ पिघल जाएगी और पोलर बियर खतरे में आ जाएंगे और क्योंकि बर्फ नहीं होगी तो वो ड्राउन हो जाएंगे। पोलर बियर आर डाइंग ड्यू टू ग्लोबल वार्मिंग। ऐसे ऐसे शीर्षक हमारे को बताए जाते हैं ग्लोबल वार्मिंग का जब भी बात होती है। दूसरी बात होती है, अगर ये काफी नहीं है तो हमें बताया जाता है कि पॉल्यूशन के कारण, ग्लोबल वार्मिंग के कारण पॉल्यूशन बहुत बढ़ गया है और मैन मेड एक्टिविटीज के कारण बहुत बढ़ गया है और ग्रीन हाउस गैसेस बढ़ गई हैं और कुछ समय के बाद इन ग्रीन हाउस गैसेस में से एक गैस को निकाल दिया जाता है और बताया जाता है कि कार्बन डाइऑक्साइड के कारण बहुत ज़्यादा प्रॉब्लम आने वाली है, क्योंकि कार्बन डाइऑक्साइड हमारे लिए बहुत प्रॉब्लम क्रिएट करने वाली है। तो ये स्टोरीज जब भी हम ग्लोबल वार्मिंग के बारे में बात करते हैं, ये एक अनसर्टेनिटी वाली बातें और एक फियर क्रिएट करने वाली बातें एक एजेंडा के तौर पे हमारे को बताई जाती हैं। और अगर इसकी थोड़ी तहकीकात करें तो मैन कब से ये रिलेट हुआ है, जब से ये यूनाइटेड नेशंस आईपीसीसी बनी है, इंटरनेशनल पैनल ऑन क्लाइमेट चेंज, जब से ये बनी है तब से इसका एक ही एजेंडा है कि मैन और उसकी एक्टिविटीज को किसी ना किसी तरह ग्लोबल वार्मिंग के टेम्परेचर्स के साथ जोड़ा जाए। कार्बन डाइऑक्साइड, अल्गोर, ट्रुथ और ये जितनी भी यूनाइटेड नेशंस की आईपीसीसी की जो जितनी भी रिपोर्ट्स इनिशियल आई हैं, सारी कार्बन डाइऑक्साइड को बड़े ढंग से हॉकी स्टिक कर्व बना के कि जैसे जैसे बनता जाएगा वैसे वैसे ग्लोबल टेम्परेचर्स बढ़ते जाएंगे और बढ़ने के बाहर हो जाएंगे और ह्यूमन सिविलाइजेशन सारी अस्तित्व ही खत्म हो जाएगा। तो ये सारी की सारी यूनाइटेड नेशंस की रिपोर्ट ग्लोबल वार्मिंग के बारे में है और ये सारी की सारी हमारे अंदर फियर क्रिएट करती है। क्या ये सच है? नहीं, सच इससे बिल्कुल विपरीत है। कार्बन डाइऑक्साइड जो है वो एसेंशियल पार्ट है हमारी फूड चेन का। अब ह्यूमन पॉपुलेशन 6 बिलियन है, 9 बिलियन ईयर्स तक एक्सपेक्टेड है, थोड़े सालों में हो जाएगी, 10 अगले डिकेड में। तो उसको सबसे ज्यादा जरूरत क्या है? प्लांट्स की है और प्लांट्स खाने के लिए फूड चेन में बहुत इंपॉर्टेंट है और उसको सबसे ज्यादा जरूरत कार्बन डाइऑक्साइड की। तो एक नेचुरल फिनोमिना जो बैलेंसिंग कर रहे हैं, तो कार्बन डाइऑक्साइड की कोई हुआ नहीं है। तो पोल्यूशन दूसरी चीज है जो इन्होंने बताया है कि पोल्यूशन करके हो रहा है। तो पोल्यूशन दो तरह से होता है, एक है नेचुरल और एक है वॉल्केनिक। तो अगर हम जियोलॉजिकल पास्ट में जाएं तो ऐसे ऐसे वॉल्केनोज हुए जो 2,000 किलोमीटर की वॉल्केनिक इरप्शंस हुई हैं यहाँ पे पास्ट में, जो बहुत ही भयानक रही हैं, लेकिन वो एक नेचुरल प्रक्रिया है और वो पोल्यूशन अलग चीज है। और कई अब जब मैन मेड है, इंडस्ट्रियलाइजेशन अभी 100-200 साल से आया है, तो ये एक अलग प्रक्रिया है। तो दोनों का ग्लोबल वार्मिंग से कोई लेना देना नहीं है। ये एक जियोलॉजिकल प्रक्रिया और एक मैन मेड प्रक्रिया है और इसका वार्मिंग से कोई लेना देना है या नहीं है, ये एक बहुत साइंटिफिक विषय था और इसको सिर्फ मैन के साथ जोड़ दिया गया, जबकि ऐसा कुछ भी नहीं है। और फ्लड्स और साइक्लोन्स बढ़ रहे हैं ये ग्लोबल वार्मिंग के कारण, ये एक नेचुरल सी प्रक्रिया है। वो मैं आपको बाद में बताता हूँ कि कैसे मैं इसके बारे में विश्लेषण करते हैं। तो ये जो दूसरी चीज़ है जो अभी तक हम देख रहे हैं कि इसका कोई साइंटिफिक एविडेंस नहीं है, सिर्फ एक ये ऐसा हो गया, पोलर बियर आ गया, पोल्यूशन आ गया, कार्बन डाइऑक्साइड बढ़ गई इसलिए टेम्परेचर बढ़ रहे हैं, कोई भी साइंटिफिक एविडेंस नहीं कि इससे क्लाइमेट चेंज इंक्रीज हो रहा है या डिक्रीज हो रहा है। तो मैं इसमें क्लाइमेट चेंज में कैसे आया, लद्दाख में मैं काम कर रहा था और मेरा अच्छा काम चल रहा था हिमालयस में ग्राउंड वाटर एक्सप्लोरेशन का। और अगर उसमें मैंने ये देखा कि जब मैं यहाँ पे था तो ग्लोबल वार्मिंग तो बेस्ट पार्ट है यहाँ पे लद्दाख में, क्योंकि जब वार्मिंग टाइम्स में यहाँ पे लद्दाख में आओ तो ये एक जन्नत नजर आती है, सर्दियों में आओ तो यहाँ पे सब कुछ फ्रीज होता है, इवन कि पानी जैसे मैंने दिखाया आपको वो भी फ्रीज हो जाता है, शुरू हो जाता है। तो वार्मिंग is the best part to be on this planet Earth. We are fortunate, our generation is fortunate, next generation would be fortunate कि अब हम वार्मिंग टाइम्स में इस planet पे आए हैं। Imagine if we cannot enjoy warming, just imagine ask people who have been to Antarctica or Arctic और उनकी लाइफ कैसी होती है। That is what it is to be in global cooling times. तो ये हमारे को देखना है कि कैसे हम वार्मिंग के साथ रह सकते हैं। अगर हम मेरी इसमें इन्वॉल्वमेंट सिर्फ यही हुई कि मैं पानी के साथ पहले काम कर रहा था, ग्राउंड वाटर एक्सप्लोरेशन के साथ, और माउंटेन्स पहले डिवॉइड थे ग्राउंड वाटर के साथ, रिसोर्सेज के साथ। तो मैं उसमें कॉन्सेप्चुअल मॉडल बनाया, ऑकरेंस एंड मूवमेंट ऑफ ग्राउंड वाटर रिसोर्सेज, और उसका एक मॉडल प्रस्तुत किया। फिर मैं 6 हाइड्रोस्टैटिक ग्राफिक जोन से 7 हाइड्रोस्टैटिक ग्राफिक जोन में आया और कैसे डिफरेंट थ्योरीज देके, कॉन्सेप्चुअल मॉडल देके ग्राउंड वाटर एक्सप्लोर किया हमने लद्दाख में, हिमाचल में भी किया, फिर लद्दाख में भी किया, फिर मतलब ये 7 जोन भी किया। और आई वॉज वेरी हैप्पी एक्सप्लोरिंग वाटर रिसोर्सेज फॉर इंडियन आर्मी एंड सिविल पॉपुलेशन। और ये सियाचिन में भी हमने पानी निकाला, ग्राउंड वाटर गिनीज बुक में भी हमारा नाम आया। तो ये सब कुछ मीडिया से भी काफी अच्छी कवरेज मिल रही थी। पर जब ये क्लाइमेट की बात से मैं कैसे जुड़ा, तो 2007 का इंसिडेंट है कि हमने ये पढ़ा एक रिपोर्ट है कि ह्यूमन एक्टिविटीज आर रिस्पॉन्सिबल आर रेजिंग द टेम्परेचर। लद्दाख में जब आप काम कर रहे हो यहाँ पे कोई ह्यूमन एक्टिविटी नहीं है इतनी ज्यादा, ना इंडस्ट्रियलाइजेशन है, पर यहाँ पे फिर भी इम्पैक्ट क्लाइमेट चेंज का आप देख सकते हो। फिर यूनाइटेड नेशंस की भी रिपोर्ट आई कि ये यूनाइटेड नेशंस ब्ला 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 करके और इन्होंने टेम्परेचर्स बढ़ा दिए हैं और कार्बन डाइऑक्साइड बढ़ा दी है और ये सब ग्रीन हाउस गैसेस बढ़ गई हैं मैन मेड एक्टिविटीज के कारण। पर यहाँ पे कहीं पे लद्दाख में मैन मेड एक्टिविटीज नहीं थी, फिर भी ये सब कुछ बहुत अजीब सा लग रहा था मेरे को कि यहाँ पे कुछ भी नहीं है और फिर भी यहाँ पे ये कैसे ये हमारे साइंटिस्ट लोग ग्रीन हाउस गैसेस को ग्लोबल वार्मिंग के साथ जोड़ रहे हैं और कैसे ये मैन मेड एक्टिविटीज को ग्लोबल वार्मिंग के साथ जोड़ रहे हैं। ये तो एक नेचुरल सी प्रक्रिया है ग्लोबल वार्मिंग और ग्लोबल कूलिंग। तो ये फिर मैंने एक स्टेटमेंट दी थी कि ये जो जितना भी पैनिक है ग्लोबल वार्मिंग का 2008 में, कि ये सब कुछ सही नहीं है, ये मिसप्लेस्ड है बिल्कुल। अब ये इतना कहना ही सही नहीं था। फिर मैंने एक कॉन्सेप्ट सा, जब इतने साल लद्दाख में काम कर रहे थे तो एक कॉन्सेप्ट सा बनाया, गॉड गिव मी द करेज टू चेंज द थिंग्स आई कैन, पोल्यूशन इन टेक्नोलॉजी, except the things I cannot change, climate, global warming and global cooling, serenity and wisdom to know the difference। तो ये एक ओल्ड प्रोवर्ब थी जिसने मेरी जिंदगी को बदला। तो इसको मैंने क्लाइमेट चेंज में डाल के देखा। तो पोल्यूशन और टेक्नोलॉजी को हम चेंज कर सकते हैं, वो हमारी बनाई हुई है, इंसान की बनाई हुई है, जिससे हम पोल्यूशन क्रिएट कर रहे हैं। अगर हम टेक्नोलॉजी इंप्रूव कर देंगे, ग्रीन टेक्नोलॉजी ले आएंगे, अच्छी अपने रिवर्स को अच्छा पोल्यूट नहीं करेंगे, अपनी वातावरण को साफ रखेंगे, तो हम पोल्यूशन को और कार्बन डाइऑक्साइड लेवल्स को, ग्रीन हाउस गैसेस को रोक सकते हैं। लेकिन क्लाइमेट चेंज को रोकना असंभव है, वो होना ही है, वो नेचुरल प्रक्रिया है। वो मैं आगे से थोड़ा सा बताऊंगा आपको। फिर जब ये सारी बातें आ गई तो नेचुरल सी बात है, एक जियोलॉजिस्ट के नाते ये बोलना ही काफी नहीं था, मुझे उसको प्रूव भी करना था। तो अब क्या हुआ, मैं पानी तो पहले से एक्सप्लोर करता था, ड्रिल करता था लद्दाख में, और फिर मैंने देखा कि जितने भी एविडेंसेस थे हमारे एक्सप्लोरेशन के, चाहे वो पीलियो चैनल्स थे, चाहे वो पीलियो क्लाइमेटिक सिग्नेचर्स थे, चाहे वो ग्लेशियल रिसीड को हम देखते थे, मोरेन्स कहाँ पे हैं, पेरियोलेक्स को देखते थे, और बाकी भी जितने भी एविडेंसेस इधर उधर से जो मिलते थे हमारे को, सर्कमस्टेंशियल एविडेंसेस, उनको सबको मैंने पानी के साथ साथ क्लाइमेट के रूप में भी अब देखना शुरू किया। अब प्रायोरिटी थी सेडिमेंट्स और क्लाइमेट चेंज सिग्नेचर्स को आइडेंटिफाई करने की, तो ये किया। तो उसी टाइम इत्तेफाकन मेरे को एक प्रोजेक्ट मिला था ले ऑग्यूमेंटेशन वाटर सप्लाई स्कीम का। तो वहाँ पे आर्मी के लिए मैं बोरवेल कर रहा था। मैंने बड़ा सिंपल सा एक किया, जब हम एक्सप्लोरेशन करके ड्रिल करने लगे तो मैंने देखा कि जो ड्रिलिंग टेक्नोलॉजी हमारी बड़ी सही है। तो एक साइट एक्सप्लोर की जहाँ पे पेलियो चैनल्स मेरे को नजर आ रहे थे, तो वहाँ पे जब हमने ड्रिलिंग शुरू की, अब सैंपल्स में पानी के लिए नहीं दिख रहा था, पानी के लिए तो देख ही रहा था, लेकिन सैंपल्स मैंने क्लाइमेट सिग्नेचर्स के लिए भी देखने शुरू कर दिए कि कौन कौन से सैंपल्स आ रहे हैं, लेकिन उसकी क्या एफिनिटीज अब ले में है, तो हमारी या तो बैथलिट से होनी चाहिए, क्या हो सकता है कि स्टोक कांगड़ी के सेडिमेंट्स वहाँ से अक्रॉस आ गए हों इंडस के, तो वहाँ पे हमारे को वो मिलने चाहिए। तो मैंने ये देखा कि पहले 20-30 फुट तक तो हमारे को ये ऑल्टरनेट लेयर्स मिल रही थी ग्रेनाइट की, जिसमें डोमिनेंस थी, फिर सिल्टस्टोन और सैंड की डोमिनेंस थी, पेबल्स की, और फिर धीरे धीरे जैसे हम नीचे जा रहे थे तो हमने देखा कि जो कंसंट्रेशन है सारी, वो सारी की सारी बदल रही है। किसकी बदल रही है, मतलब ये जो सेडिमेंट्स हैं ना तो वो खारदुंग ग्लेशियर के हैं और ना ही वो स्टोक कांगड़ी के हैं। तो किसके थे वो? ये थे इंडस ग्लेशियर के बेसिकली। तो इंडस ग्लेशियर के जो सेडिमेंट्स हमारे पास आए तो हमने देखा इसका कि ये इंडस ग्लेशियर के सेडिमेंट्स थे, ना तो ये खारदुंग से मिलते थे बैथलिट से, ना ही ये स्टोक कांगड़ी के सेडिमेंट्री रॉक से मिलते थे। तो हमने ये बेसिकली ये निष्कर्ष निकाला कि ये दीज हैव बीन ट्रांसपोर्टेड फ्रॉम मानसरोवर ग्रेट डिस्टेंस, और ये इंडस ग्लेशियर के सेडिमेंट्स थे, क्योंकि ग्लेशियर रिमेन्स थे। तो ये इंडस ग्लेशियर जब था, ये काफी दूर से आया, तो फर्स्ट टाइम हमने ये इंडस ग्लेशियर की एविडेंसेस ढूंढ लिए थे। अब इंडस ग्लेशियर का मतलब था कि अगर हम 11,714 साल मान लें, जो डैनिश बोरवेल्स का डेटिंग कर रखी है आइस कोर्स की उन्होंने आर्टिक में या ग्रीनलैंड में, तो उसकी डेटिंग के हिसाब से मान लें तो लास्ट आइस एज खत्म हो गई थी 11,700 साल पहले। तो उसके बाद जितने भी ये एविडेंसेस मिल रहे थे तो ये सारे के सारे तब खत्म हो गई थी, और उसके बाद ये एक्टिविटीज शुरू हुई लेटरल खारदुंगला ग्लेशियर की और स्टोक कांगड़ी ग्लेशियर का। इसका वो हुआ, पर वो अलग से पीछे आ जाता है, लेकिन हमारे को एविडेंसेस मिल गए थे। तो ग्लोबल वार्मिंग का पहला एविडेंस हमारे को ये मिल गया था जब हम बोरवेल कर रहे थे आर्मी के लिए। तो उसके बाद नेक्स्ट हमारा था कि आगे हम जा रहे थे, क्या बोलते, चांगथंग की तरफ। तो वहां पे हमारे को ये रॉक्स में, ग्रेनाइट्स में ये सिग्नेचर्स मिले जो बड़े टिपिकल से सिग्नेचर्स थे। आते जाते हमने पहले भी बहुत बार देखा था इनको, लेकिन अब ये समझ में आने लगे कि ये सिग्नेचर्स हमेशा ये रहती थी उत्सुकता कि ये जियोमॉर्फिक फीचर्स बने कैसे यहाँ पे इतनी हाइट में। ये कम से कम 30-40 मीटर ये ऊपर थे, ये क्या बोलते, अगर ये मान लें यहाँ पे ये जो चीज है रिवर इंडस यहाँ पे बह रहा था, तो ये सिग्नेचर्स काफी ऊपर थे। तो मैंने ये देखा जब ये ऑब्जर्व करने लगे तो ये बिल्कुल सी की तरह थे। कुछ यहाँ पे प्रोटूबरेंस थी, फिर ये डिप्रेशन था, फिर ये प्रोटूबरेंस थी, और फिर ये डिप्रेशन था, और ये ऐसे ऐसे देखा। तो हमने नोट किया कि ये सारे के सारे करीब 10 साइकिल्स ऐसे हमने मेजर किया। तो 10 साइकिल्स थी, हर 4 साल के 4 साइकिल्स, जैसे एक साइकिल ये होगी तो ये हमने देखा कि ये अल्फाबेट सी को रिप्रेजेंट करता है। ये फिर ये यहाँ पे प्रोटूबरेंस है, फिर ये अल्फाबेट सी है, यहाँ पे डिप्रेशन है, ये है। तो ऐसे ऐसे करके हमने रिकंस्ट्रक्ट करके, और ये यहाँ पे हम खड़े हैं, देखिए हमारी हाइट कितनी है, 5 फीट है, तो ये 12 फीट के करीब यहाँ से इसका डिफरेंस है। पर इनकी दोनों की हाइट ये यूनिफॉर्मिटी है, और ये अप्रोक्सीमेटली ये आधा है उसकी हाइट से। मतलब ये अगर वो 12 फीट था तो ये 5 या 6 फीट है। तो मतलब हमने ये देखा कि कैसे हर 4 साल के बाद, हर 4 साइकिल्स के बाद ये आधी साइकिल आ रही है। तो उसको अब हमने जब इसको एक्सट्रापोलेट किया तो ये पाया कि जो क्लाइमेट चेंज है वो एक यूनिफॉर्म हॉकी स्टिक कर्व की तरह नहीं चलता, ये चलता है एक सी कर्व की तरह, जहाँ पे ग्लोबल वार्मिंग और ग्लोबल कूलिंग ऑल्टरनेट करते रहते हैं। तो कर्विलिनियर पैटर्न है, और आइस एज कर्विलिनियरली ट्रांसफॉर्म्ड इनटू वार्मिंग, एंड वार्मिंग मैक्सिमा, फिर बीच वाला जो पोर्शन है वो सारा का सारा ये वार्मिंग मैक्सिमा आ जाता है, और फिर उसके बाद ये आइस एज आ जाती है। तो ये बड़ा इंटरेस्टिंग सा फिनोमिना हमने ऑब्जर्व किया। तो ये मैं बता ही चुका हूँ कि 8 साइकिल्स थी, और जब इसको फिर मैथमेटिकल कैलकुलेशन की 11,700 साल से पहले, और फिर इसके बाद यहाँ से इन साइकिल्स को 10 साइकिल्स को, तो हर साइकिल की एज अप्रॉक्सीमेटली हमारे पास आ गई। जो कंप्लीट साइकिल थी उसकी 1338.6 ईयर्स, और जो हाफ साइकिल थी उसकी आ गई 669.3 ईयर्स। तो अगर हम देखें एक साल कितना होता है 365 दिन का, और एक दिन होता है 24 घंटे का। ऐसी जो एक क्लाइमेट साइकिल है उसकी अगर कैलकुलेशन हमने की इन साइकिल्स के हिसाब से, और जो आई स्कोर हमारे को वहां से मिला था, जो डेट्स मिली थी, उसके कारण हमारी ये आ गई। तो अल्फाबेट सी का क्या मतलब है, तो जो अगर हम अगर हम पहले वाली फिगर में जाएं तो ये आइसेज है, फिर यहाँ पे वार्मिंग शुरू होती है तो ये मेल्टिंग शुरू हो जाती है। जब मेल्टिंग शुरू होती है तो पानी ज्यादा आता है, तो ये रॉक्स को ज्यादा काटता है, और ये सेंटर में क्या है, ये ग्लोबल वार्मिंग मैक्सिमा है। और फिर कूलिंग शुरू होती है, और कूलिंग के बाद क्या होता है, ये आइसेज आ जाती है। तो आइसेज, वार्मिंग मैक्सिमा, कूलिंग और फिर आइसेज। तो ये हर बार ये अपनी प्रक्रिया ऐसे चलती रहती है, इसका इरिस्पेक्टिव ऑफ कि हम क्या कर रहे हैं कि क्या नहीं कर रहे हैं। जैसे सन की साइकिल है वैसे ही ये साइकिल चल रही है, ग्लोबल वार्मिंग की भी और ग्लोबल कूलिंग की भी। अगर वो कुछ डेट्स डैनिश बोरवेल्स की जो सैंपल्स हैं उसके कारण ग्लेशियल मैक्सिमा जो लास्ट था आइसेज वो बदल जाती है, तो ये थोड़ी कैलकुलेशन बदल जाएंगी, अदरवाइज हमारी ऑब्जर्वेशंस बिल्कुल सही है। अगर इसी मॉडल को हम प्रस्तुत करें तो ये बेसिकली दर्शाता है 10 साइकिल्स, ये 11,715 साल से लेके आगे अगर 3,000 ये अगली फ्यूचर प्रेडिक्शंस भी हम इस चार्ट के थ्रू कर सकते हैं। तो ये इंटरेस्टिंग है बहुत ज़्यादा। तो अगर मैं देखूं कि ये 2010 में क्या हुआ, फ्लड्स बहुत आए थे, और बद्रीनाथ में भी, केदारनाथ में भी आए थे। तो उसमें क्या हुआ था, हमारे को बहुत ज़्यादा वार्मिंग के कारण और अनप्रेसिडेंटेड बारिश यहाँ पे हुई थी, फ्लैश फ्लडिंग एक्टिविटी हुई थी। तो वो हमने 2010 बेसिकली मैक्सिमा था, और उसके बाद अब हम बोल रहे हैं कि धीरे 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 कर्विलिनियरली क्या हो रहा है, वो उसकी तरह आ रहा है। अगर हम इसको देख लें, ये लामायुरू के लिए ये मैं थोड़ा सा डिस्कस करूंगा 1006 में। तो उसमें क्या हुआ था, वहां पे भी एक ग्लेशियल लेक फ्लडिंग एक्टिविटी हुई थी। तो यहाँ पे भी हम दिखा रहे हैं कि ये ग्लेशियल मैक्सिमा था, यहाँ पे ग्लोबल वार्मिंग मैक्सिमा था। अगर थेम्स रिवर फ्रीज हुई थी, तो ये हम यहाँ पे दिखा पा रहे हैं कि ये कैसे 1677 में फ्रोजन थेम्स रिवर, जो थेम्स रिवर थी वो फ्रीज हो गई थी। तो वहां पे ग्लोबल कूलिंग, लिटिल आइसेज हम बता रहे हैं। तो अब इस मॉडल के तहत लोथल की सिविलाइजेशन भी, मेरा ख्याल से अगर हम रामायण काल में भी चले जाएं, तो जो ब्रिज था वो उस टाइम हिमालयस में ग्लेशियर ज्यादा थे, सी लेवल वहाँ पे ओशन लेवल कम था, तो वो उसकी जो लेवल है वो भी हम एक्यूरेटली मेजर कर सकते हैं मेरा ख्याल। और फिर उसके बाद महाभारत में जो द्वारका की समर्जेंस है वो भी इस ग्लोबल वार्मिंग के थ्रू, यहाँ पे देखेंगे लोथल की जो समर्जेंस आ रही है वो भी ग्लोबल वार्मिंग मैक्सिमा यहाँ पे आ रहा है। तो इस तरह से हम काफी हद तक इस चार्ट से आगे की जो प्रिडिक्शंस हैं, जो फ्यूचर में आने वाला है, तो नेक्स्ट हमारे को वरी करने की बात ये है कि वार्मिंग की नहीं, अगर हमारी नेक्स्ट मतलब 2-3 जनरेशन 4 जनरेशन के बाद, तो ये 2300 में कूलिंग मतलब अभी कूलिंग शुरू हो जाएगी थोड़े सालों बाद, और फिर 2300 में लिटिल जैसे थेम्स फ्रीज हो गई थी वैसे कई रिवर्स यहाँ पे फ्रीज हो जाएंगी इन फ्यूचर प्रेडिक्शंस में। ये मॉडल से हम जान सकते हैं, पर इसको भी काफी डिटेल में करने की काम की जरूरत है। ये तो जो एविडेंसेस हमने सर्कमस्टेंशियल एविडेंसेस लिए थे, जैसे थीम्स का मैंने बताया आपको, लिटिल आइसेज थी 3336 वो साल की, तो ये हाल हो गया था, और ये आगे 2334 में ऐसा हाल फिर होने वाला है। तो जब फ्रीज हो जाएगा सब कुछ तो ले फ्लड्स जो थे 2010 के, वो भी हमने बताया कैसे ये कोइंसाइड करते हैं हाफ साइकिल के लिए। तो केदारनाथ में जो बद्रीनाथ में भी, जो केदारनाथ में जो अपने वो फ्लड्स आए थे और ये लेह में जो आए थे, उधर हम देख रहे हैं कि जो एक्यूमुलेशन हुई है सेडिमेंट्स की 10 फीट के करीब हुई है, 10 या 11 फीट के करीब हुई है। तो 3 मीटर के करीब एक्यूमुलेशन दोनों जगह हुई है। तो ये उतना ही पानी निकाल पाए हैं जितना ये कोइंसाइड करता है हाफ साइकिल के थ्रू। और अगर ये फुल साइकिल होती तो आप देखिए कितना, इमेजिन कीजिए कितनी ये डिस्ट्रक्शन करता। तो ये लेह फ्लड्स का ही सीन है, कैसे ये उसने 2010 में किया। और ये फिर आप देख रहे हैं कि लेक्स का माउंटेन हाइड्रोजियोलॉजी में बहुत ही इंपॉर्टेंट रोल है। अब जितने भी माउंटेन लेक्स हैं वो ये सेंट्रल हिमालयस में, ये जैसे अब ग्लेशियर रिसीड करते हैं, अब ये देख रहे हैं ये सारा का सारा ग्लेशियर है। और यहाँ पे क्या है कि ये यहाँ पे कोई ब्लॉकेड हो गई है और यहाँ पे ये लेक बन गया। और ये लेक तब तक पानी जमा करता रहेगा जब तक ये थ्रेशोल्ड ये ब्रेक नहीं होता। और जब ये थ्रेशोल्ड ब्रेक हो जाएगा तो हम फ्लैश फ्लडिंग बोलते हैं, जिसकी केदारनाथ में हुई थी अपना। तो इस तरह से ग्लेशियल लेक्स बहुत इंपॉर्टेंट सोर्स है, हमारे रिजर्वॉयर्स भी हैं। पर जब ये फ्लडिंग के पर ये अगर इनका ब्रीच हो जाए या हाइड्रोस्टैटिक डिसइक्विलिब्रियम हो जाता है तो यहाँ पे बहुत तगड़ी फ्लडिंग आ जाती है। तो ये जैसे ब्रीच हुआ, ऐसे ही 1006 में जो लामायुरु ग्लेशियर था, ग्लेशियर लेक था, ये देख रहे हैं आप पूरी की पूरी बाउंड्री, ये पूरी की पूरी बाउंड्री लेक की थी। पेलियो ग्लेशिएटेड लेक था ये सारा का सारा। और यहाँ पे आके ये ब्रीच कर गया, हाइड्रोस्टैटिक डिसइक्विलिब्रियम हुआ, यहाँ से ये ब्रीच कर गया और ये फ्लडिंग हो गई यहाँ पे। और ये जो बाकी रिमेन्स रह गई हैं अभी भी इसको लेक के रूप में देख सकते हैं। पर अब इसका बिल्कुल जो सरफेस है वो ऐसा लगता है जैसे मूनलैंड वाला होता है। तो बेसिकली क्या है कि जो ग्लेशियर्स हैं हिमालयस में और ग्लेशियर लेक्स हैं वो लाइफलाइन है वाटर रिसोर्सेज की। मोर देन 1 बिलियन पॉपुलेशन को फीड करती है ये। लेकिन मेजॉरिटी ऑफ द ग्लेशियर्स जो हैं हिमालयस के वो एक्सटिंक्ट हो चुके हैं या ऑन द वर्ज ऑफ एक्सटिंक्शन है, बहुत कम रह गए हैं। अब ये खरदुंगला का ग्लेशियर है जो फीड करता है ले टाउन को, तो आप देख रहे हैं कितना कम मात्रा में रह गई है। ये काफी पहले की तस्वीर है। तो हमारे को ये देखना है कि ये इसको प्रिजर्व करने की बहुत ज़्यादा ज़रूरत है। और इसको हमने जैसे जो पहले वाला बोरवेल मैंने ड्रिल किया था और वहाँ से लेके हमने जब इसको, जो मैंने आपको दिखाई स्लाइड जहाँ से मेरा आया था, और जो ये ट्रेस आउट किया, ये अप्रॉक्सीमेटली 22 या 23 किलोमीटर के करीब ये 23 किलोमीटर के करीब ये रिसीड कर चुका है। तो ये डॉक्यूमेंट्री एविडेंस है कि ये 30 किलोमीटर लास्ट आइस एज के बाद डिक्रीज कर गया। तो 11,714 साल के बाद ये यहाँ पे इतना रिसीड किया हुआ है। फिर अच्छा ये डबल हो गया। तो ये इतना रिसीड करके अब क्या है कि ये नदर्न साइड है इसका। तो ये अब जो रिमेनिंग ग्लेशियर यहाँ पे रह गया है तो ये 1 किलोमीटर के करीब रह गया है। तो जब तक ये है तब तक हम वाटर रिसोर्सेज की कोई कमी नहीं आ सकती ले टाउन में। लेकिन जब ये खत्म हो जाएगा तो फिर क्राइसिस बहुत स्ट्रॉन्ग आने वाले हैं। तो ये इम्पोर्टेंट चीज़ है। तो और इम्पोर्टेंट चीज़ है, यहाँ पे कोई इंडस्ट्रियलाइजेशन नहीं थी और these glaciers became extinct or on the verge of extinction much before 1000 में। ये सारे के सारे ग्लेशियर्स 1000 साल पहले, मतलब 11000 साल से ये रिसीड करना शुरू हुए थे, लेकिन 1000 साल तक ये ऑलमोस्ट कई एक्सटिंक्ट हो गए, कई ऑन द वर्ज ऑफ एक्सटिंक्शन है। तो मैन का इसमें कोई रोल नजर नहीं आता। ये इंपॉर्टेंट चीज है इसमें, क्योंकि एक्सटिंक्ट 1000 साल पहले हो गए ये ग्लेशियर। फिर एक और ग्लेशियर है, मौका मिला सियाचिन में काम करने का, सियाचिन ग्लेशियर में। तो जब हम ग्लेशियर में काम कर रहे थे सियाचिन ग्लेशियर में, तो देखा वहां पे ये ग्लेशियर की स्नाउट है। ये देखिए ये सारे का सारा ग्लेशियर है इधर, और ये सारी की सारी यहाँ पे ये स्नाउट है इसकी। तो जो इसकी जो स्नाउट है बेसिकली वो हम देख रहे हैं कि 2005 तक जब हम गए थे तब मैं थोड़ा लेट गया था, पर इससे पहले भी गया था और फिर 2005 में भी। तो इतना था और ये काफी रिसीड कर चुका था। फिर हमने डॉक्यूमेंट कैसे किया इसको, एक वाई पॉइंट है, वाई जंक्शन है, वहां पे ड्रिल किए बोरवेल्स, वहां के सैंपल्स लिए और यहाँ के सैंपल्स कंपेयर किए। फिर देखा हमने कि ये 78 के करीब उस टाइम था, तो अब ये मेरे ख्याल से ज्यादा हो गया होगा। ये डॉक्यूमेंट करने वाली बात है, ये अब कितना रिसीड कर चुका है ग्लेशियर सियाचिन। तो इधर भी काराकोरम, ये काराकोरम रेंज में आ गया बेसिकली। तो काराकोरम रेंज का भी मतलब मैं सोचता था काफी अच्छे ग्लेशियर्स होंगे, और मेरे को डीवीओ जाने का भी मौका मिला। तो वहां पे भी जो ग्लेशियर्स का हाल है अभी, जब गलवान के उस एपिसोड में आई वाज देयर, वहां पे जब ग्राउंड वाटर के लिए एक्सप्लोर कर रहे थे, तो वहां पे भी ग्लेशियर्स है ही नहीं, तो ये बहुत कम रह गए हैं। पर ये भी मैंने देखा सियाचिन भी 78 किलोमीटर के करीब, काराकोरम में भी इम्पैक्ट बहुत ज्यादा है, ग्लोबल वार्मिंग के कारण ग्लेशियर्स बहुत रिसीड कर रहे हैं। तो ये एक बहुत अहम विषय है। लेक्स भी यहाँ पे श्रिंक कर रहे हैं हिमालयाज में। अगर हम ये देखें तो ये सोमरारी लेक था, हमारे को यहाँ पे एक्सप्लोरेशन और ड्रिलिंग करने का मौका मिला। तो हमने ये देखा कि अब ये देखते हैं कि यहाँ पे हम, ये ड्रिलिंग साइट थी हमारी, तो यहाँ पे कितनी ये रिसीड आ गया है। तो इसको जब हमने कैलकुलेट किया तो अप्रोक्सीमेटली हमने ये देखा कि ये 8 मीटर्स, ये जो है अप्रोक्सीमेटली 1 मीटर 1000 मीटर 1000 साल में ये रिसीड किया हुआ है। तो मतलब ये जो अप्रोक्सीमेट है, ये सारे का सारा 1 मीटर इन 1000 ईयर्स ये रिसीड करा हुआ है। ये हमारी एस्टिमेशन है अभी, और बड़ी अच्छी डॉक्यूमेंटेशन हो सकती है अगर हम इसको और अच्छे ढंग से करें। सॉरी, ये सोमरारी लेक था, फिर ये पैंगोंग लेक 3 इडियट्स के बाद बहुत फेमस हो गया, और हर कोई अब ये यहाँ पे आके करना चाहता है। पर हमारे को लुकुंग में भी जो स्टार्टिंग पॉइंट है इसको, और थाकू में भी ड्रिल करने का मौका मिला। अब यहाँ पे बेसिकली ये 4 फिंगर्स और 8 फिंगर्स आपने बहुत सुनी होंगी। तो जब हम ये डॉक्यूमेंट कर रहे थे तो हमारे को पूरे ऐसे एविडेंस मिले कि पहले ये जो पैंगोंग लेक था, ये लेक नहीं था, ये ट्रिब्यूटरी थी, ये रिवर था बेसिकली, और ये ट्रिब्यूटरी थी शोक रिवर की। और ये शोक रिवर से कब ये उसमें बदल गया, ये भी मेरे ख्याल से 1000 ईयर्स के आसपास ही होगा, जब इसके मतलब यहाँ पे जो ग्लेशियर्स फीड कर रहे थे इसको, उसका फ्लो कम हो गया और ये रिवर बन गया। तो ये एक इम्पॉर्टेंट चीज थी कि ये कैसे पहले, क्योंकि ये फ्रेश वाटर रिवर था और फिर ये अब सॉल्ट वाटर लेक है, हाईएस्ट मेरे ख्याल से वन ऑफ द हाईएस्ट सॉल्ट वाटर लेक्स हैं। तो ये बहुत इंपॉर्टेंट चीज थी। तो ये देख रहे हैं हम, ये यहाँ से आ रहा है, सॉरी ये यहाँ से आ रहा है, तो ये चाइना का हिस्सा है, और यहाँ पे ये 4 फिंगर्स और 8 फिंगर्स की जो बातें हम सुनते रहते हैं, और ये श्योक यहाँ पे है। तो श्योक रिवर पे ये मिल जाता है यहाँ पे। तो ये ट्रिब्यूटरी थी इसकी, और फिर कैसे ये ग्लोबल वार्मिंग के कारण पैंगोंग लेक जो है, ये डाइंग रिवर मैं इसको बोलता हूँ, कि ये कैसे ग्लोबल वार्मिंग का लेक्स पे कैसे और रिवर्स पे कैसे इम्पैक्ट रहा है हिमालय में, बहुत इंटरेस्टिंग है ये समझने। अब ये इम्पैक्ट ऑफ क्लाइमेट चेंज, इम्पैक्ट ऑफ क्लाइमेट चेंज अगर हम एज ए जियोलॉजिस्ट अगर हम मेरे से बात करेंगे कि क्या मैं समझता हूँ इसमें, तो ये है कि ये ग्लेशियल मेल्ट होंगे। ग्लेशियल मेल्ट होंगे तो मोर फ्लैश फ्लडिंग होगी गर्मियों में। उसके कारण क्या होगा, जब सी लेवल राइज कर जाएगा तो मानसून की फ्रीक्वेंसी बढ़ जाएगी, साइक्लोन्स की फ्रीक्वेंसी भी बढ़ जाएगी, और मानसून की कैरिंग कैपेसिटी बढ़ जाएगी, और फिर वहां पे भी हमारे को, तो बेसिकली क्या है कि ग्लोबल वार्मिंग के कारण हम देख रहे हैं वाटर इन द सिस्टम इंक्रीजेस, मतलब प्रेसिपिटेशन इन द फॉर्म ऑफ फ्रेश वाटर इंक्रीज कर जाएगा। पर प्रेसिपिटेशन जो स्नो के मामले में है वो होगी, लेकिन वो इतनी नहीं होगी जितनी पहले होती थी, और वो सारा का सारा मेल्ट होएगा, तो उसके कारण फ्लड होंगे। और जियोलॉजी के नाते हम इसको ऐसे मानेंगे कि दिस इज जस्ट एक्टिंग एज अ ट्रांसपोर्टिंग एजेंसी टू डिपॉजिट, टू ट्रांसपोर्ट ऑल द सेडिमेंट्स, जितने भी सेडिमेंट्स डिपॉजिट हुए थे ड्यूरिंग ग्लोबल कूलिंग टाइम्स में, उसको ट्रांसपोर्ट करना है। पहाड़ों की जैसे खरुंगला की चोटी से ले जाके इंडस में डालना, इंडस ले जाएगी अपना बे ऑफ बंगाल में, ट्रांसपोर्ट करते करते गंगा पर्वत से टर्न लेगी, और वहां से जितने सेडिमेंट्स होंगे और करते 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 चर्निंग करते करते वहां पे जाके वो डिपॉजिट करेंगी अरेबियन सी में, और फिर वहां पे एक और सेडिमेंटेशन और सेडिमेंट्री प्रोसेस शुरू हो जाएगा। उसके बाद रॉक्स फॉर्मेशन शुरू हो जाएंगी, और फिर वो एक रॉक साइकिल है बेसिकली ट्रांसपोर्टिंग एजेंसी, और ये रॉक साइकिल को कंप्लीट करती है ग्लोबल वार्मिंग और ग्लोबल कूलिंग। ग्लोबल वार्मिंग फेनोमिना है, अल्टीमेटली इट इज अ जियोलॉजिकल फेनोमिना। और जो ग्लोबल वार्मिंग या ग्लोबल कूलिंग इज अ जियोलॉजिकल फिनोमेना, इट हैज नथिंग टू डू विद मैन मेड एक्टिविटीज और टेम्परेचर। ठीक है, टेम्परेचर इंक्रीज होएगा डिक्रीज होएगा, वो थोड़ी स्मॉल प्रक्रिया है, उससे पोल्यूशन लेवल्स का हम देख सकते हैं। लेकिन जो ग्लोबल वार्मिंग है, जैसे वो सूरज का दिन, सूरज का टाइम है और चंद्रमा नाइट रात, मतलब जब सूरज और जैसे हम डे एंड नाइट देखते हैं, उसी तरह ग्लोबल वार्मिंग और ग्लोबल कूलिंग की साइकिल्स को भी अंडरस्टैंड करने की जरूरत है। तो अब इसका जो इम्पैक्ट अगर हम हिमालयन ग्लेशियर्स में, जैसे मैं पहले ही बता चुका हूँ, तो हिमालयन ग्लेशियर्स में जो बहुत बड़ा इम्पैक्ट हो चुका है, उस सारे के सारे ये रिसीड कर चुके हैं या एक्सटिंक्ट हो चुके हैं या ऑन द वर्ज ऑफ एक्सटिंक्शन है। ये बहुत बड़ी स्टेटमेंट मैं बोल रहा हूँ, लेकिन ये ट्रुथ है, जिसे मैंने आपको ग्लेशियर्स का दिखाया। और काराकोरम रेंज में भी कोई अच्छी स्थिति नहीं है। अगर काराकोरम में हो भी जाएगा तो भी हमारे वो हिमालयन पार्ट में बहुत कम उसका असर होने वाला है, क्योंकि वो श्योक से पानी सारा चला जाएगा, तो श्योक तो सीधा आगे जाके मिलेगी, वो हमारे को कोई इतना ज़्यादा उसका बेनिफिट नहीं है। लेकिन ओवरऑल सिनेरियो क्या है कि हमारे हिमालयन में ग्लेशियर्स को बचाने की बहुत आवश्यकता है, और बचाने की भी आवश्यकता है और उनको प्रिजर्व करने की भी आवश्यकता है। और कैसे करना है कि जैसे रोड्स जो हैं, रोड्स के लिए हम वो टनल्स बना लें, उसके लिए रोड्स के लिए हम खारदुंगला को क्लियर ना करें या तंगनंगला को क्लियर ना करें, या इन ग्लेशियर्स को, उसमें जैसे अब रोहतांग में टनल बन गई है तो ऊपर का ग्लेशियर प्रिजर्व हो जाएगा, तो उससे क्या होगा, मनाली के लिए पानी के रिसोर्सेज बढ़ जाएंगे, बिकॉज दे आर द स्टोर हाउसेज ऑफ फ्रेश वाटर रिसोर्सेज, ऐसे समझना चाहिए हमारे को। पर यहाँ पे हम खुश होते हैं कि जब हम रोड क्लियर कर लेते हैं और ग्लेशियर्स को एक्सटिंक्ट कर देते हैं, ये बड़ी एक दुविधा वाली बात है। ये मैन मेड एक्टिविटी है, हम ग्लेशियर्स को ही नहीं प्रिजर्व करना चाहते हैं यहाँ, तो टनल्स बन जाए, उससे सब अच्छा हो जाए। फिर फ्लैश फ्लडिंग एक्टिविटी है, डिस्ट्रक्शन ऑफ इंडस सिविलाइज, तो जितनी भी सरस्वती वैली सिविलाइजेशन थी, इंडस वैली सिविलाइजेशन आई, हड़प्पन सिविलाइजेशन आई, तो ये सारे की सारी जितनी भी सिविलाइजेशन थी कैसे एक्सटिंक्ट होगी, इनका इम्पैक्ट है ग्लोबल वार्मिंग के साथ। ग्लोबल वार्मिंग के कारण जब भी साइकिल बदलती है, कूलिंग होती है तो फिर ये हो जाता है, फिर जब वार्मिंग होती है फिर फ्लडिंग होती है, फिर ये बह जाती थी, क्योंकि ये इंडस वैली वैलीज के अलोंग सिविलाइजेशन थी, तो इनका इम्पैक्ट जो था वो क्लाइमेट चेंज के साथ बहुत ज्यादा था। देखें तो इम्पैक्ट ऑफ वार्मिंग ऑन फ्रेश वाटर रिसोर्सेज मैंने पहले बता दिया। अब क्या होगा, जब आपके पास ग्लेशियर्स ही नहीं रहेंगे तो फ्रेश वाटर रिसोर्सेज पहले से स्क्वीज्ड अप है। इंडस रिवर पहले कितनी बड़ी थी, श्योक रिवर कम से कम कितना बड़ा उसका स्पैन था, 8 से 10 किलोमीटर तक का हम उसके डाया देख सकते हैं जो ग्लेशियर है, पर अब वो बिल्कुल स्क्वीज्ड अप है। इंडस रिवर भी ऐसी है, और जितने भी मेजर रिवर्स हैं सिर्फ ये सीजन्स में मतलब बढ़ जाती हैं इनकी जब गर्मियाँ होती हैं, लेकिन अदरवाइज ये स्क्वीज्ड अप है बिकॉज ग्लेशियर्स का मात्रा बहुत कम हो गई है। तो जितनी भी वाटर सप्लाई स्कीम्स हैं जो स्प्रिंग वाटर सोर्सेज में बेस्ड हैं या जो है, वो भी खतरे में पड़ सकती हैं, जो छोटी छोटी गाँव को फीड करती हैं, क्योंकि स्प्रिंग सोर्सेज में भी इसका बहुत इम्पैक्ट पड़ेगा और कॉस्ट ऑफ वाटर इंक्रीज कर जाएगा। तो रिवर्स भी हमने देखा, जैसे पैंगोंग रिवर था, फिर वो लेक बन गया और वो भी अब सॉल्ट वाटर लेक हो गया, तो उसमें रिसोर्सेज की ऐसे ऐसे धीरे धीरे क्रंच आना शुरू हो जाएगा वाटर रिसोर्सेज का आने वाले समय में, जैसे जैसे वार्मिंग बढ़ती रहेगी। बिल्डिंग्स में इसका देख रहे हैं हम बहुत इंपॉर्टेंट इम्पैक्ट देख सकते हैं। अगर हम यहाँ पे देखेंगे, ये ले पैलेस है, इसकी बिल्डिंग्स जो थी, इसके जो शीशे थे बड़े छोटे छोटे थे, खिड़कियां इसकी बहुत छोटी छोटी थी, पर अब इसी के नीचे जो नए घर बन रहे हैं उनमें बड़े बड़े शीशे नजर आ रहे हैं आपको, छोटे छोटे शीशे कम हो गए। तो ये क्या है, वार्मिंग को डिपिक्ट करता है। ऐसे ये मोनेस्ट्रीज हैं, यहाँ पे छोटे छोटे शीशे हैं, जो नई मोनेस्ट्रीज बन रही है उनमें सारे शीशे ही शीशे हैं। तो ये ग्लोबल कूलिंग और ग्लोबल वार्मिंग को आप बिल्डिंग के पैटर्न से भी देख सकते हैं। और ये मॉडर्न बिल्डिंग्स हैं, इनको अब सिर्फ शीशे ही चाहिए, तो ये भी एक विषय है कि कैसे हम इसको केटर करते हैं। एनर्जी का भी इसमें बहुत फ्यूचरिस्टिक अगर सिनेरियो देखें, जब हिमालयस में ग्लेशियर ही नहीं रहेंगे, या ग्लेशियर जैसे मैं बोल रहा हूँ कि एक्सटिंक्ट हैं या ऑन द वर्ज ऑफ एक्सटिंक्शन हो रहे हैं, तो आपके पास पानी की मात्रा हिमालयस में बहुत कम आने वाली है ग्लोबल वार्मिंग के कारण। तो फिर क्या है, बेसिकली जितने भी हाइडल पावर प्रोजेक्ट्स हैं, अगर बाई चांस हमारी कूलिंग टाइम्स नहीं आते तो वार्मिंग टाइम के कारण जितनी भी हाइडल पावर में जितनी भी इन्वेस्टमेंट्स हैं वो खतरे में आ सकती हैं। फ्लैश फ्लडिंग हो सकती है, डैम्स की लाइफ भी 50, सीमेंट की लाइफ जैसे 50 से 70 साल तक होती है, तो उनकी भी लाइफ है, तो वो कितना कितना वो कर सकते हैं। तो ये देखते हैं हम कि जो हाइडल पावर प्रोजेक्ट्स हैं वो भी सारे वो आ सकते हैं साइक्लोन्स के कारण। कोस्टल्स में जैसे फ्लोरिडा में जो अगर हम देखेंगे तो ईस्टर्न पार्ट ऑफ अमेरिका, उसमें साइक्लोन्स की ज़्यादा मात्रा आ जाएगी, और वेस्टर्न पार्ट ऑफ यूरोप, उसमें भी साइक्लोन्स की ज़्यादा मात्रा आ जाएगी। तो ये हमारे को देखने वाली बातें हैं कि क्यों ज़्यादा आ जाएंगी, क्योंकि अब आर्टिक में ग्लेशियर्स की, हिमालयस में तो खत्म हो गए ग्लेशियर्स, इतने ज़्यादा नहीं रहे, तो हमारे को इतना ज़्यादा जो हमारी इंडस वैली सिविलाइजेशन थी, जो पुरानी सिविलाइजेशन थी, वो सारी इन ग्लेशियर्स के कारण खत्म हो गई है। लेकिन अब जब आर्टिक और एंटार्क्टिक की जब बात हम करते हैं, तो वहां पे जो इम्पैक्ट होने वाला है वो अमेरिका और यूरोप में ज्यादा होने वाला है उसकी, क्योंकि लैंड सबमर्जेंस, डेनमार्क इतना क्यों परेशान है, क्योंकि वो, और ये अपना पोलैंड, ये सारे के सारे मतलब ऑलमोस्ट कोस्टल कंट्रीज हैं, और ये एकदम अगर थोड़ा सा भी सी लेवल बढ़ता है तो इनमें सबसे ज्यादा इनको ड्राउनिंग, जैसे हमारी द्वारका सबमर्ज हो गई थी, तो इनको भी अपने कोस्टल रीजन्स की सिटीज को ड्राउन होने का बहुत ज्यादा खतरा है। तो और ये हो भी रहा है कि फ्लोरिडा में जैसे बहुत ज्यादा साइक्लोन्स आ रहे हैं, या तो हमारे को ये देखने वाली बात है कि जो कोस्टल रीजन्स हैं वहाँ पे साइक्लोन्स बढ़ेंगे, और जो माउंटेन रीजन्स हैं वहाँ पे हमारे को इन्वेस्टमेंट्स अपनी एनर्जी के बारे में भी देखने पड़ेंगे। तो अब इतनी सारा ये मैंने भी बता दिया, तो आपको सारा ऐसे ही लग रहा होगा कि ये तो और ज्यादा पिक्चर भयानक हो गई है, पर ऐसा कुछ नहीं है। अगर हम नेचर को समझ जाएं और नेचर के साथ चलें, तो जैसे पानी की मात्रा बहुत ज़्यादा अच्छी होने वाली है, तो अब ग्लेशियर नहीं रहेंगे, लेकिन हमारे को जो अपने ग्राउंड वाटर रिसोर्सेज हैं और जो रिवर्स हैं, जो रेन वाटर्स के कारण इतना पानी आएगा, उसको हम चैनलाइज कैसे करेंगे, ये उसकी तरफ हम पानी हमारे मात्रा में बढ़ेगा, लेकिन वो बड़ा इरेटिक सा होगा, और उसके साथ और नया सोच के साथ उसके साथ हमारे को करना पड़ेगा, तो पानी की मात्रा तो बढ़ेगी बढ़ेगी। और ये देख सकते हो आपकी 100 ये मतलब 1000 साल पहले की बात है, तो ये मोनेस्ट्री जब थी तो उसके लेक के पास बनी हुई, लेक था वहाँ पे, तो मोनेस्ट्री नहीं थी। फिर लामा आए यूरू, उन्होंने उसके टाइम में ये लेक बर्स्ट किया, और वहाँ पे जो रॉक्स थे वहाँ पे ये सस्टेनेबल हैबिटेट बन गया। ठीक है, और अभी तक ये मोनेस्ट्रीज 1000 साल पुरानी है, वहीं पे टिकी हुई हैं, और ग्लेशियर्स भी पड़ते हैं वहाँ पे, ग्लेशियर लेक्स भी हैं, थे पेलियो ग्लेशियर लेक्स जो बर्स्ट कर गए, और ये फ्रेजाइल एनवायरनमेंट लगती है, लेकिन जब आप जियोलॉजिकल स्टेबलाइजेशन देखोगे तो बहुत सही जगह में है, माउंटेन पीक है इसकी, और हार्ड रॉक पे इसकी सारी मॉनेस्ट्री बनी हुई है, लेकिन दूर से लगता है कि ये उसमें क्रम्पल कर जाएगी, लेकिन ये बहुत इंटरेस्टिंग है। तो ग्लोबल वार्मिंग जो है, मिसकंसेप्शन आप निकाल दीजिए, आदमी इतना बड़ा नहीं है कि वो ग्लोबल वार्मिंग को कुछ भी इम्पैक्ट कर सके। वो एक कर सकता है, पोल्यूशन क्रिएट कर सकता है, पोल्यूटिंग टेक्नोलॉजीज हैं, द मूवमेंट पोल्यूटिंग टेक्नोलॉजीज ठीक हो जाएंगी, आपका पोल्यूशन लेवल ठीक हो जाएगा, और अब हमारे को उसकी तरफ काम भी करना है। फिर हमें अपनी वाटर बॉडीज को पोल्यूट नहीं करना है, अपने लैंड को पोल्यूट नहीं करना है, अपनी एयर को पोल्यूट नहीं करना है, तो उससे हमारा पोल्यूशन लेवल अच्छा हो जाएगा, हम अच्छी तरह रह सकते हैं। पर उसके कारण हम क्लाइमेट चेंज को नहीं बदल सकते, क्योंकि क्लाइमेट चेंज, ग्लोबल वार्मिंग और ग्लोबल कूलिंग एक नेचुरल प्रक्रिया है, ये हमारे को समझने की बात है। पोल्यूटिंग टेक्नोलॉजीज को इंप्रूव करने से हम पोल्यूशन के लेवल्स बदल सकते हैं, अपनी हैबिट्स को इंप्रूव करने के कारण हम, जो गंगा आपके दिल्ली में बह रही है जो बिल्कुल पोल्यूटेड है, तो वो उसको हम इंप्रूव कर सकते हैं, उसका पोल्यूशन लेवल, और उसको हम पीने योग्य बना सकते हैं पानी को। पर ये नहीं हो सकता कि आप पानी की पर ये कह लें कि हम इससे अगर हमने पोल्यूशन ठीक कर लिया तो हमने ग्लोबल वार्मिंग को भी कंट्रोल कर लिया। ये एक बहुत बड़ी मिसकंसेप्शन हमारे को यूनाइटेड नेशंस आईपीसीसी ने दी है, और मेरे को पता नहीं वो जब थोड़े सालों बाद जब हकीकत समझ में आएगी, तो उसका पीस प्राइज दिया गया है उसको यूनाइटेड नेशंस का, तो वो भी मेरे ख्याल से ये वापस होना चाहिए, क्योंकि ये बहुत बड़ी मिसकंसेप्शन उन्होंने पैदा की। तो अगर ग्लोबल वार्मिंग है तो बेस्ट पार्ट ऑफ दिस प्लानट है, तो क्योंकि देखिए आप ड्रेस अच्छा पहन सकती हैं, आप घूम सकते हैं, आप नॉर्मल पानी को पी सकते हैं। ग्लोबल कूलिंग टाइम्स बिल्कुल विपरीत है। आप आर्टिक में जाके और अंटार्कटिक वाले ड्रेस देखिए, आप कभी ऐसे बैठ नहीं सकते, आप बीचेस में नहीं जा सकते, आप निकर नहीं पहन सकते, क्योंकि वहां पे ग्लोबल कूलिंग टाइम्स हैं। तो जो ग्लोबल वार्मिंग है, दिस इज द बेस्ट पार्ट टू बी ऑन दिस प्लैनेट अर्थ। नहीं तो जिसको ये पसंद नहीं आता, ये जितने भी लोग इसके बारे में कुछ गलत अफवाह उड़ा रहे हैं या गलत कह रहे हैं तो ग्लोबल आर्टिक और अंटार्कटिक में 6-6 महीने या 1-1 साल रह के देखिए, फिर आपको पता लगेगा कि इसकी अहमियत कितनी ज्यादा है वार्मिंग की। तो मैं ये टेडेक्स टॉक मैंने की थी बहुत पहले, तो वो भी मेरा ख्याल जयपुर में ही की थी, या जयपुर में या उदयपुर में की थी शायद, किसी इंस्टीट्यूट ने मेरे को बुलाया था। तो क्लाइमेट चेंज जो है बेसिकली इज ए जियोलॉजिकल फिनोमिना, जैसे मैंने पहले बोला। उसको therefore the solutions to combat climate change need to be geological। वो solutions क्या हैं? Build sustainable habitats in geologically favorable locations, environments। और वो क्या है? भैया कोस्ट के पास मत जाओ। कोणार्क का टेम्पल हजारों साल पहले से बना हुआ है, कोस्ट के पास है, उड़ीसा में। कोस्ट दूर है, उसको आज तक कोई छू नहीं। इस तरह की अगर हम इंस्टीट्यूट्स बनाएंगे, जैसे कोणार्क टेम्पल थे, या जो जितने भी हमारे पुराने टेम्पल जिनको जो सोलर यूनिवर्सिटी है बेसिकली, तो इस तरह के जो इंस्टीट्यूट्स तो हम बना देते हैं लेकिन वो गड़बड़ हो जाते हैं, क्योंकि कहीं ना कहीं क्योंकि वो जियोलॉजिकली स्टेबल लोकेशन पे नहीं है। लेकिन जो हमारी पुरानी परंपरा रही है, चाहे वो हम कोणार्क टेम्पल को ले लें या लद्दाख की मोनेस्ट्रीज को ले लें, हजार साल पहले 10 में उनका कुछ भी बाल बांका नहीं हुआ था। ऐसे ही आप देख लो, जब सुनामी आई थी तो पुराने स्ट्रक्चर्स को कुछ नहीं हुआ था, जितनी नई बिल्डिंग्स थी सब तहस नहस हो गई थी। तो ये जो मंदिर थे, ये मंदिर नहीं है बेसिकली, ये मोनेस्ट्री जो ऐसे नहीं बनाने नहीं देते थे पहाड़ों के ऊपर, उनका एक सिग्निफिकेंस था। जो ले पैलेस है यहाँ पे वही 500-600 साल है, 9 स्टोरीज है, हाईएस्ट सिस्मिक जोन में है। तो सिंपल जियोलॉजिकली फेवरेबल लोकेशन में अगर आप कुछ भी करेंगे तो वही बेहतर है, अन्यथा सब प्रॉब्लम में आ जाएगा। तो ये सिंपल से सॉल्यूशन है। कोस्ट में अपना आप जितना भी आपकी कोस्ट में मत जाइए, जहाँ पे भी वो पुराने मंदिर बने हुए हैं कोस्ट के पास, उससे थोड़ा सा पीछे रहिए और उसको एक बॉर्डर लाइन मान लीजिए, तो आपको साइक्लोन ज़्यादा प्रभावित नहीं करेंगे। ऐसे ही जितने पुराने रिवर पेलियो चैनल्स हैं उनको छोड़ दीजिए, लैंड ग्रैब करने के चक्कर में और उसको करने के चक्कर में वो रिवर्स जो पेलियो चैनल्स हैं उनको हम ऑक्यूपाई कर देते हैं, फिर फ्लैश फ्लड आता है और फिर वो सारे का सारा तहस नहस हो जाता है, और फिर हम कहते हैं ग्लोबल वार्मिंग को लेते हैं। अगर हम देखेंगे तो पुरानी सभ्यता के साथ अगर हम रहेंगे तो हम बेस्ट रहेंगे सस्टेनेबल जियोलॉजिकल लोकेशंस में, अन्यथा हम प्रॉब्लम में आ जाएंगे। और अपनी मैं लास्ट स्लाइड जो मैंने फर्स्ट स्लाइड से कंक्लूड की थी, मैं उसी से ही खत्म करना चाहूंगा। देख रहे हैं कि एक स्ट्रीम जो है ये वाली, ये सारी की सारी फ्रीज हो चुकी है। अभी ये मैंने लेटेस्ट खींची है, यहाँ पे मैं लद्दाख में हूँ, तो ये सारी की सारी फ्रीज हो, और ये ग्लोबल कूलिंग टाइम्स को दर्शाती है इन फ्यूचर। और ये जो है ये वार्मिंग टाइम को, जब भी वार्मिंग आएगी तो पानी आएगा, जब भी कूलिंग आएगी तो फ्रीजिंग आएगा। तो ये स्लाइड ये जो थोड़ी सी जब हम यहाँ पे अभी ट्रेवर्स कर रहे थे, तो ये मेरे को ग्लोबल कूलिंग और ग्लोबल वार्मिंग टाइम्स को एक्सप्लेन करने में सबके लिए बहुत अहम है। और ऐसी कूलिंग आएगी तो ये सारी की सारी जमनी शुरू हो जाएगी। अगर मैं थोड़े दिनों के बाद जाऊंगा तो ये वाली स्ट्रीम भी जमी होगी, तो वो ग्लोबल कूलिंग टाइम्स हैं। अगर वार्मिंग टाइम्स हमारे को चाहिए तो पानी बहते रहने दीजिए, कीजिए, अन्यथा ग्लोबल कूलिंग टाइम्स की तरह हम सब फ्रीज हो जाएंगे। धन्यवाद। Enjoy global warming. That's the best part to be on this planet Earth.
Okay, so I hope all of you have enjoyed the video sent by the sir, and everybody have understood it. Now going forward with the session, I would like to give a brief introduction of Professor Sandeep Singh from the Department of Earth Science, IIT Roorkee. Professor Sandeep Singh is a faculty of Earth Science at IIT Roorkee. In addition to this position, between 2014 to 2018, he had held a responsibility of Dean Alumni Affairs and International Relationship in IIT Roorkee. He completed his PhD in Earth Science from the IIT Roorkee and the year 1994. While pursuing PhD degree in the year 1989, he joined as a research scientist B, and then later on as a faculty to the Department of Earth Science from the same university. He has been doing research work in Himalayas for more than 3 decades and now has undertaken various geological expeditions for further northwest to northeastern Himalayas. Professor Singh has published a large number of research papers, books, and edited volumes and reputed journals. He had also undertaken expeditions worldwide. He has acquired the Boy Scouts Fellowship and went to Australia. He is the first recipient of Professor H. Reid Gold Medal for his research on granites of Himalayas in the year 2005. Professor Sandeep Singh has designed and started a new course on isotope geology. His area of excellence is crystallography and mineralogy, igneous petrology, isotope geology, Himalayan tectonic, geochronology, isotope geology, exhumation process, SR isotopes in water system, and so on. He is an active member of various institutions and committees. He has several fellowships under his belt. And Dr. Sandeep has supervised many PhD scholars. Apart from this, he has also been involved in strategic projects for national importance like broad gauge railway lines, and Shivaji statue project from Mumbai. Now, on this thought, I would like to invite Professor Sandeep Singh from the Department of Earth Science, IIT Roorkee. Sir, you're most welcome.
Thank you, Priyanka. I'll start my presentation, which will be on global warming. Again, this is the same line what Ritesh has been talking. But I'm not going the way Ritesh has gone. I don't know what is happening. This is not coming up. Can you see the?
Yes, sir, the slide is shared, but sir, you have to open your PowerPoint so that it can be displayed on.
Okay. Okay, hold on. So, I'll
Yes,
be
slide is there, sir.
talking about the global warming, which is myth or reality. I know Ritesh has gone more like a story without much of the content into it, and he was trying to correlate everything with the global warming and global cooling. But that is not exactly what has been happening in the world. So, because he has given already a problem to all of us, but before going into it, I think we have to be clear what are different components which we are looking at. One is the weather, which is defined as the state of the atmosphere at some place and time, which is usually expressed in terms of temperature, air pressure, humidity, wind speed, and this is a short time one. Weather is short time. When we are talking about the climate, we are defined the term as the average or the mean of weather elements such as temperature and precipitation over 30 years. And so the time period is very important for explaining different components, whether we are talking about weather or we are talking about climate. As soon as we are entering into the climate, then we are looking at the material for last 30 years cycle. So what exactly is the climate? The climate is the aggregate pattern of weather, meaning averages, extremes, timing, and spatial distribution. They contain hot and cold, cloudy and clear, humid and dry, drizzles and downpour, snowfall, snowpack and snow melt, blizzard, tornado and typhoons. And the climate change means a altered pattern of these normal cycles. And the global average temperature is just one measure of the state of the global climate. If there is a small temperature change, there is a big change in the overall pattern. Although climate change is global, the ecological impact are often local. So we have to look at the small changes, whatever is happening in the global climate. If you see the temperature variation in last 545 million years of the Earth's climate, then you will see that there is a shifted repeated between ice house and greenhouse conditions. And the temperature changes in geological time is respond to natural processes, and these processes are still active at present and influence our climate. If you see this diagram, you'll find then that there are different ice ages at different geological time in past. And if we look at the combined data, which is showing repeated cold and warm climate, that is starting from about 545 million years, coming up to the present time, you can see that there are different ups and downs of the temperature, starting from the warm to colder, and even this colder, the down anomaly, they are also going from different temperature to different temperature. And if you see this overall pattern of the planet Earth, we are talking about the temperature on the surface. It indicates that we are still in the colder climate as compared to what has been happened in the say Cambrian time, or for that matter even up to the very recent times. If you see the instrumental record, they show the increase in temperature. So if you see the lower diagram over here, then you are having these different kinks in this one. And like around 50 million years ago, there was a collision between India and Indian plate and the Eurasian plate, where we started having the formation of Himalayas. So weather is variable, but can be time to indicate climate trend. Therefore, climate scientists can use weather data plus proxy data to help them identify previous trends to improve their predictions of future trends. The climate scientists who are studying the past climate, they are known as the paleoclimatologists, and the science is known as the paleoclimatology. So there are different proxies. The proxies are the preserved physical characteristic of the past that stand in for direct measurement, so that we know what must have had happened in the past. So the proxies allow scientists to reconstruct past conditions before records were kept. So there are historical records or there are geological records. The geological records can be extracted from these different proxies. The proxies are like ice cores, tree rings, fossilized pollens, corals, lakes and ocean sediments, speleothems, and many more. And each type of the proxy has a span and a resolution. Because like everyone has got its own constraints. Similarly, each proxies has got their own constraints. They can only be used for certain time and also with certain resolution. So the span influence, how far into past we can look into by the particular proxy, and the resolution describes how fine span the climate information gathered from the particular proxies. Proxy can also be overlapped, and some proxy cover partial, some full, and the multiple proxies are used to see the coherent picture of the climate, and that is what has been done by many people. They have started looking at different proxies to work out what are the changes in the past. Uh, if you look at the ice cores, the Vostok ice cores provide the longest continuous record of Antarctic climate history, which goes up to 400,000 years of the climate history. And this is a Vostok's ice core is basically a Lemon Dorothy Earth Observatory program where the NSF was involved, and it is, you can see that it is about 3 kilometer, more than 3.5 kilometer deep ice cores, which have been studied by these scientists, and they have come up with different data set. And if you see the right diagram, you can see that there are various changes in the temperature which has been worked out from the ice cores. So ice core is one proxy where people have used different methods like dust, how much dust is there, what are the CO2 content which was trapped in the bubbles into that, or what are the oxygen isotopes which has been which people have worked out from the ice cores, and on that basis they have come up what is the temperature changes in the geological past. The another one is the tree ring, which one can study, where we have the first, it's a growth, and every growth, there are two types of growth. One is the light colored one, and another is dark colored one. The light colored growth represent the rainy season, whereas the dark colored one show the dry season. And then there are also other effects in the tree rings, and one can study them, and one can count each tree ring and find out because each pair of the growth rings tells us whether how much year old is that particular tree. Similarly, if you see the coral also are having similar growth rings, and then there are different techniques by which people have been studying them and coming up with different data. So I'm just telling you what are different proxies. I'm not going into much details of that. And then there are lake sediments as well. So lake sediment is also known as the WAS, which is having again dark and lighter color growth, or the sedimentation of the sediments over there. And on that basis, one can really count how much old is the lake sediment. But this is the condition when only we are having a normal growth. If there is any disturbance, that will be recorded into these different proxies as well. So similar way, what we have done, we happen to get the ODP core from the Kargulian Plateau, which is in the Indian Ocean. And from there, what we did, we tried to work out different proxies along with the strontium isotopic analysis. So these proxies are the different foraminifers, which are the fossils. And actually, this is the fossil identification and listing has been done by one of my colleagues, and I did the strontium isotopic analysis. So this is our own work. And in this one, if you see, there are certain species which are warm water, and then there are certain species which are of the cold water. So when we started looking at that, then we found that there are certain warm species which have started erupting out and getting fossilized in this core, and we could see them. And if you see these strontium isotopic signatures, you see there are two different peaks, and this peak coincide with the Paleocene-Eocene boundary. That means people have already worked out that at Paleocene-Eocene boundary there is a big global warming. But if you see at this point, there is a big jump, and after that it again became normal. And here this strontium isotope is showing us that there is a not was one spike, rather there is more than one spike. This is the first time anyone has really worked out the double spike. People have been working out the single spikes, but this is the first time anyone has worked for the double spike. So these are different proxies which on the basis of that one can really work out how much is the change in the temperature or the change in the normal roots. So with this, I know everyone is overshooting the time. So I put this talk to a bare minimum and giving a thought to all of you. Whether you want to look at the temperature of planet, that we are still in the colder region, or we are looking at the lower diagram where we can see that the change in temperature is much higher. Because if you see both the diagrams, they are showing this similar data, but only thing is that the vertical scale has been changed. If you see the lower diagram, the change in temperature is only 0.5 degrees centigrade. Whereas in the above diagram, if you see the change is about -6 to +14 degrees centigrade. And in this one, on the rightmost, if you see, even the projection which people have made, the up in 2050, by 2050, the temperature can go only up to 4 degrees, not beyond that. But still people are crying that there is a global warming happening at the moment. So what I do agree with Ritesh that the crying of the global warming started only when United Nations has put up a subcommittee. So we have to really look into it and see what exactly we want to interpret and how we want to do our precautions so that this myth, I call it a myth, people call it a reality, is going on, and we have to look at the factual data and interpret it the way we want. And thank you very much.
Thank you very much, sir. Thanks a lot for such a nice and wonderful session on climate change, myth or reality. So this is Dr. Varun from this side. We have received some questions from the participants. I would like to some questions from the participants.
Yeah, please.
So the first question is from Keshe Argawi. He wants to know, he just want to some idea about what is the impact of COVID-19 on climate change. This is a very simple question.
Cash, actually, as I told you, when we are talking about climate change, we are looking at a cycle of 30 years. And COVID-19 has only started for about few months. So you really cannot say that anything can happen with the COVID-19 with the climate change. I think I'm clear with that.
Yeah. Thank you very much, sir. The next question is from Aparna. She wants to know, how can we explore proxies in an island?
Aparna, it depends upon what exactly you are looking at. Because if you're in an island, then it depends upon how big is the island. And what are the evidences available over there? Because islands can be coral island or can also be a volcanic island. So what exactly you are looking at, that you have to first see and then decide accordingly. I think I'm clear about it. Am I clear?
Yes, sir. Yeah, thank you, sir. So the next question is from Amrish Saini. He wants to know how are we going to witness more proxies due to exposure of permafrost regions due to melting of ice at the higher altitudes, higher elevation.
I'm not clear what exactly he wants to ask. Proxies are the material from where we are extracting the information. So what he wants to ask is not very clear to me. Can you elaborate it so that I can answer your question properly?
He just asked that can we are going to witness more proxies due to exposure of permafrost regions due to melting of ice.
Proxies in what sense?
He's not clear.
Let him ask directly.
Yeah, Amrish, if you are there, then you can ask directly. Amrish?
Good afternoon, sir.
Yeah.
Very informative session. So, sir, I wanted to ask, actually, I have read about any article. So, in Siberian region, so the layer permafrost region, if ice is melting there, and so the permafrost region, some bacteria, they found some new bacteria and some different kind of proxies. So I wanted to ask about that if
Amrish, when ice is melting, the temperature is changing, and when the temperature is changing, there are different bacteria which starts growing up. Okay, so it is possible, and you do not know what are the microclimate generated around that. And all the proxies, whatever people are trying to work out, will depend upon what are the climatic situation over there and how the people are going to use that. So predicting it is very difficult task as of now.
Thank you, sir. Thank you.
Well, thanks a lot, sir. Thank you very much for such a nice and insightful lecture on climate change. So now, sir, we are moving forward for our next session, that is validatory function. So I would like to call upon Ms. Priyanka Roy to proceed further. Priyanka.
Okay. Thank you. Thank you.
Thank you very much, sir.
Thank you, sir. Thank you, Dr. Varun Mishra. So now that we have come to the last phase of our convention, that is, we are on the end of the session. Now we are starting with our validatory program. Good afternoon, everyone. Good afternoon, our eminent guest, Honorable Pro President Ma'am Ritu Gilhotra, Honorable President Sir Dr. Jagdish Rai Dutra, Dr. Shruti Kanga, Coordinator of Center for Climate Change, Dr. Suraj Kumar Singh, Coordinator of Sustainable Development, and faculty members, and all who are present here. I, Priyanka Roy, welcome you on behalf of Suresh Ken Bihar University for the validatory program of 7th Annual International Convention on Climate Change and Water Research that has commenced on the 5th of November 2020. Now, this year's perspective for the convention is sustainable development, and we are going further. And on this note, I would like to give a brief introduction of our pro-president, ma'am, Dr. Ritu Gilhotra. She is a former Dean Research and Principal of Pharmacy in University of Suresh Ken Bihar University. She has published many research papers nationally and internationally, and under her guidance, Suresh Ken Bihar University has gained new heights of excellence. Now, on this thought, I would invite Dr. Ritu Gilhotra ma'am to take this session forward with a welcome address. Madam Ritu Gilhotra.
Thank you, Priyanka. Good afternoon, everyone. And my warm greetings to all the dignitaries present on the board today, and particularly the organizing team of C3W, with a key conference theme that is the Building Sustainable Society for Future. So my heartiest congratulations to the organizing team and the respected guests who have been present for the 3 days convention from 5th, 6th, and today is the third day, I believe, 7th day, third day of this convention, that is the International Convention on Climate Change and Water, and which is proudly bringing together a lot of leading academicians, scientists, industrial experts around the globe and India to share their experience and research findings of all the aspects of the climate change and sustainable development and natural resource management. So this is a wonderful initiative of our university to go with this, center of the research in climate change. And we have been, working on this idea since now 7-8 years, that this idea and this center has been, conceptualized. And I'm really very happy to see the way it has been, growing and shaping up, and all the hard work that the center is putting up converges and, in a way manifests itself into this international convention, which is, to my understanding today, is one of the most important event as far as I see on the national platform, and people actually look forward for, joining this thing. And while I was in the last technical session, so I could see the enthusiasm the researchers were having while asking the questions regarding their research work. So at first the theme, that is building sustainable society for future. So the way the world has, shaped up in 2020 because of this COVID-19 situation. So what could be, better time to now actually not only theoretically discuss the sustainability, but now it is the need, or you can say the mandate of the hour. So we can actually see only the economies, the nations, the universities, the societies, the communities which are sustainable will be, going ahead and will be, carrying themselves in advancing tomorrow. So we should be basing all our practices, our ideas on sustainability by now. So I would again congratulate the organizers for keeping such a wonderful theme. I have got the reports for all the sessions that have been conducted since 5th to today, and I could see there have been many wonderful dignitaries who were on the board, including many scientists and researchers like Dr. C.P. Singh from ISRO, Professor Walia from Meghalaya, Northeastern Hill University, Dr. Srinivas, Professor Tan from Bangkok University, Professor Tiwari, Professor Liu. I could see on the day one, and there have been, around 300 participants and around 30-40 papers that have been also presented each day. Same way, the day two, we have with us Dr. Gosain, Dr. Kotru, then we have Professor Mishra, and Dr. Sharma. I'm sorry if I have, forgotten someone's name. And today also, when I joined, we were having Dr. S.K. Singh, who was, giving a very wonderful deliberation over the research work. So I find that the discussions done have been really very fruitful, and the aim with which we have been, conducting the conference is quite fulfilled. And therefore, I thank all the significant and renowned personalities who were the key speakers and who have joined hand with CCW and have given their precious time. And I look forward that they associate with us for the longer period of time. And I thank all the researchers who have actively participated. Thank you so much. And then I, in the end, congratulate the organizing team, Dr. Shruti Kanga, Dr. Suraj, Dr. Varun, Dr. Priyanka, and all the other organizers and the research scholars for conducting such a wonderful event. So thank you so much for having me for this session as well. Over to you, Priyanka. Thank you so much.
Thank you, ma'am. Thank you for such exhilarating welcome address. Now, on this thought, I would like to invite Dr. Suraj Kumar Singh, convener of C3W for 2020, for the technical session report. Sir?
Hello, a very good afternoon. Thanks a lot, ma'am, for your motivational words. And today I'll be briefing the entire 3-day convention that we have, the technical details that we discussed for last 3 days. I'll start with our first presenter, Dr. C.P. Singh, scientist in Space Application Center, Indian Space Research Organization, Ahmedabad, India. He discussed the use of geoinformatics approach in biodiversity conservation, ecosystem and habitat suitability analysis. Thereafter, we had a second talk delivered by Professor Devesh Walia, Department of Environmental Science, North Eastern Hill University, Meghalaya, India. His talk was focused on the impacts of climate variability on water resource management in northeastern parts of India. The third talk was delivered by Dr. Srinivas Bulusu, Senior Principal Scientist, CSIR National Geophysical Research Institute, Hyderabad, India. He described the changing climatic conditions during the evolution of Earth's terrestrial surface. The fourth talk was delivered by Professor Chai Chi Tang, School of Management, University of Bangkok, Thailand. He discussed the use of balanced scorecard strategy map-based models in developing sustainable livelihoods for community. The fifth talk was delivered by Professor Prakash C. Tiwari, Department of Geography, Kumaon University, India. He talked about the processes and dynamics of urban growth in Himalayan area for sustainable management. The sixth and the last talk for the day one was by Professor Liu, Center for Space and Research, Remote Sensing Center, National Central University, Taiwan. His talk was about the assessment of eco-environmental vulnerability from regional to global scales using remote sensing and GIS techniques. After this technical section, a total 30 papers were presented online on various topics of climate change and sustainable development. There was a gathering more than 400 participants from various organizations of India and world, and the planners discussed various themes related to urban planning, environmental solutions, policy makings, ecology, This was the day one. We started day two with the first talk by Professor A.K. Gosai, Emeritus Professor, Department of Civil Engineering, Indian Institute of Technology, New Delhi, India. He discussed about the water resource management policies in NCT in India. He also discussed the various hydrological modeling in Ganga River Basin. The second talk of the day was by Dr. Rajan Kumar Katru, lead strategist at Trestle Management Advisors, alumni of University of München, Germany. His talk was focused on the building of resilient society through transboundary cooperation in South Asian countries in the era of changing climate. The top talk of the day was delivered by Professor Pradeep Kumar Mishra, Department of Civil Engineering, IIT BHU, Varanasi, India. He talked about the current environmental problem caused by the communities. He also discussed how to change the scenario by community participation and self-motivation. The fourth talk of the second day was delivered by Professor Sadaf Fazal, Department of Geography, Faculty of Science, Aligarh Muslim University, Aligarh, India. He talked about the current urbanization patterns and trends in India with sustainable urban planning and management. The fifth talk of the second day was delivered by Dr. Poonam Sharma, Associate Department of Geography, University of Delhi. She discussed the relationship between the green spaces and urbanization pattern and its impact on environmental sustainability. Then after this technical rounds, there were near about 40 papers presentation online and more than 500 participations from various parts of the world. The third and the final day started with the talk by Professor Ramesh L Gardas, Department of Chemistry, Indian Institute of Technology, Madras, India. It discussed about the environmental friendly solvents for sustainable development. He also talked about green chemistry and its application in environmental management. The second talk of the third day was by Professor S.K. Singh, Senior Principal Scientist, Central Building Research Institute, Ministry of Science and Technology, Roorkee. His talk was focused on the use of sustainable construction materials for developing infrastructure. He described geopolymer materials for construction. The third talk of the third day was delivered by Dr. Gopal Krishan, scientist, National Institute of Hydrology, Ministry of Jal Shakti, Roorkee. He talked about the dynamics of groundwater and its management with its relationship to climate variability. The fourth talk of the third day was delivered by Dr. Ritesh Arya, Director, International Sustainable Energy Organization, Geneva, and is a working member of NIH Roorkee, where he briefed about the various concerns related to global warming. And the final and the validity talk was given by the esteemed Professor Sandeep Singh, Department of Earth Science, Indian Institute of Technology, Roorkee, where he talked about the various ice cores, isotopic observation, proxies, and how this can be correlated with the change in the temperature and climate. Finally, there were near about 1,250 participation from various prestigious institutions who participation. The list, I'll be listing some of them. They were IIT Mumbai, IIT Kharagpur, IIT Delhi, IIT Roorkee, Regional Remote Sensing, Lucknow, Banaras Hindar University, NIT Warangal, NIT Karnataka, Suratkal, University of Kashmir, BIT Mishra, Indian Institute of Science, Education and Research, Bhopal, University of Delhi, Aligarh Muslim University, Indian Institute of Remote Sensing, Dehradun, Punjab University, Chandigarh, Central Soil Salinity Research Institute, Regional Research Station, Lucknow, Indian Council of Agricultural Research, Kurukshetra University, and there are many more. Apart from Indian Institute University, the other foreign university who participated in the conference are University of Science Malaysia, University of Malaya, University Science Malaysia, Wuhan University, University of Copenhagen, Denmark, University of Twente, and we were getting participation from across the globe, from Southeast Asia, Africa, Middle East, South America, and the countries like Nepal, Bhutan, Bangladesh, Sri Lanka, Philippines, East Timor, Fiji, Myanmar, Afghanistan, Iran, Brazil, Albania, Morocco, Nigeria, Ethiopia, Uganda, Algeria, Mali, Cameroon, Kenya, Zimbabwe, Tanzania, Sudan. And finally, all this was compiled in the form of an abstract volume which was released on 5th November where we received near about 130 abstract, out of which 80 abstract were selected and were compiled in the form of a ISBM book that is being published by the name Journal of Climate Change and Water by Suresh Gyan Vihar University, Jaipur. And once we'll complete the convention, thereafter we'll upload the entire thing, and the same copy will be emailed to each and every individual who has participated in this convention. And with this, I conclude my technical session. Thanks a lot. Priyanka, please.
Yes, sir. Thank you for the brief information of the International Convention. Now, I would like to take this opportunity to introduce our Honorable President, Sir Jagdish Rai Rutra. Uh, uh, he has completed his PhD in MS, focused in physics, from Indian Institute of Technology, Delhi. He has joined University of Mexico as a research associate in the year in 1986. He joined University of Alabama as an assistant professor. Then he rose to the step of professor at IIT Kanpur in the year 1999. Later, he joined Dartmouth College as a professor of physics, and then he was a director of MIT School of Applied Science from the year 2013 to 2014. He discharged his duty as a dean at Modi University of Science and Technology. In the year 2018, he became the chairman of and managing director at Educatics institution, and in 2018 he joined Gurukul School of Design and chief executive officer. And presently he has an extensive experience in the field of education administration and taking Suresh Gyan Vihar University to its greater height. Now, on this note, I would invite Honorable President Sir Professor Jagdish Rai Rutra for the valedictory remark on 7th Annual International Convention on Climate Change and Water Research. Sir, you're most welcome, sir.
Thank you for the kind introduction. Honorable Chairperson, sir, Honorable Chief Mentor, sir, Honorable Pro-President, ma'am, galaxy of intellectuals, invited guests, professors, students, organizers of this conference, ladies and gentlemen, a very good afternoon to all of you. I begin with a quote from Gandhiji, as this conference is about sustainability. There is a sufficiency in the world for man's need, but not for man's greed. I repeat, there is a sufficiency in the world for man's need, but not for man's greed. If we remember this, I'm sure all our life we will make every aspect of our life, every activity sustainable. On behalf of the Suresh Gyan Vihar University, it gives me great pleasure to welcome all of you to the valedictory session of this very successful 7th Annual International Virtual Convention on Climate Change and Water, C3W 2020, entitled Sustainability in Current Scenario, Challenges and Solutions. No doubt, 2020 has been one of the most challenging years of everyone's life due to COVID and everything. Still, I'm very pleased. New developments have taken place. Last year, I had attended this conference just, I think, 3 days after my joining, and it was in live. We all met. It was very pleasant experience, but I'm very pleased that the organizers have put so much effort and invited such scintillating galaxy of people that they have made this conference as successful as it was before and using less resources. Though, of course, effort put is very great. I'm also very glad the key conference theme was building sustainable society for future, a theme of great relevance ever. It's a matter of immense pride to stand here before all of you this evening. This conference follows on the success of the pioneering C3W 2012 to C3W 2019. Inspired by the past 6 events, we have hoped to build on the community that comes together and fosters a connected and collaborative and creative international network of adoption, research, decision makers, and interested citizens. I take a moment here, and in Indian philosophy, the five elements are considered as basic to life. And those five elements, if I remember them right, are earth, water, fire, wind, and space. I repeat, earth, water, fire, wind, and space. In the tone of sustainability, if we today reconsider these five elements, I tell you, we have achieved everything through these five elements once again. Though, of course, chemistry tells us there are different number of elements, but these are what are going in making our daily life. So our ancient sages and philosophers have already told us to respect these five elements. And I'm very pleased while going through the contents of the conference, I noticed that all of these elements have been touched. This international convention has aimed to bring together leading academicians, scientists, industrial experts, researchers, and students from India and around the world to exchange and share their experience and research findings on all aspects of climate change, sustainable development and management, natural resource management, green and smart cities, disaster risk management and reduction, geoinformatics, etc. Such a meeting bringing together this knowledge at one place. I'm very pleased to know that more than 1,000, that is 1,219 participants have registered from various prestigious institutes all around the globe. There were 3 technical sessions, which have been just summarized by Dr. Suresh Sharma, comprising 60 renowned academicians, scientists, researchers, disseminating their expertise in the above-mentioned themes, and 4 sessions for paper presentation comprising 16 presentations in each session daily. Whichever paper I could attend and see, I noticed that the quality was excellent and in fact at par with the international standards. The summary of the 3 days activities have already been summarized before my presentation. So I am once again grateful to the many experts who have come to share their expertise and knowledge. I am pleased with the success of the conference and I keenly look forward to the next one. My best wishes to all of you. I have another quote for you, that is to make the most of everything that we have. Today, the community is the measure of success was how many things do we have. If we can change this in our thinking to how little we can survive on, how little do we need, I think all issues of sustainability. This is not my original quote, this is quote from Mahatma Buddha. He said, always look at how little we can survive. It is not the accumulation of resources, it is the least use of resources and leave the planet in a better position than when we received it. Thank you very much once again. It was a great conference. I once again look forward to the next one. Goodbye.
Thank you, sir. Thank you for such warm, motivating words. Now, on this note, I would like to invite Dr. Suraj Kumar Singh for the announcement of Oral Presentation Award.
Thank you, Priyanka. It was a very tough decision to select the best out of all the presentation because each and every student has taken equally pain for making his or her presentation, but still we have to go for it. So the first prize that goes for the oral presentation C3W 2020 is Durga Mohata Mato. Mato. The topic of the presentation was stream flow dynamics in the upper Jhelum catchment, northwestern Himalayas, by Department of Geography and Regional Development, University of Kashmir, India. So we can have a clapping to that student. The second place goes to Harath HM YLP. The topic of the presentation was reducing the carbon footprint in Sri Lankan data centers towards the sustainable development by Department of Environmental Management, University Rajharata, University Sri Lanka. The second prize too, there was a second prize too given to another candidate, that is Lucija Planck. That is, the topic of presentation was contribution to improvement the methodology of measuring of flows in water courses. Case study, Croatia. Department Faculty of Geotechnical Engineering, University of Zagreb, Croatia. And there was a consolation prize given to Ajoji Achen. The topic of presentation was feasibility study on sustainability of circular management of water resources in developing countries from National Water Resources Institute, Nigeria. And with this end, I thanks all the participants to have a patience, and they were very keen to participate. Thanks a lot for their paper presentation.
Thank you, sir. And congratulations to all the winners. And apart from that, congratulations to all the participants as well, because all the presentations were equally good. Now, on this note, I would like to call upon Dr. Varun Narayan Mishra for the vote of thanks. Sir.
Thanks, Priyanka. Thank you very much. Honorable President, sir, Dr. Jagdish Rai Luthra, sir. Honorable Pro-President, ma'am, Dr. Ritesh Arya, all the faculty members of Center for Climate Change and Water Research, all the academicians, researchers, ladies and gentlemen, good afternoon to all of you. It's my privilege and honor to have been asked to propose a vote of thanks on this occasion. I, on behalf of Center for Climate Change and Water Research, Suresh Gyan Vihar University, and the entire organizing team, and those who have directly or indirectly contributed to this 7th annual International Convention on Sustainability in Current Scenario, Challenges and Solutions. And on my own behalf, I extend a warm and hearty vote of thanks to all the eminent speakers for gracing the event and sharing their ideas and knowledge. I am also very much thankful to all the participants, all the paper presenters, and the audience for joining and sharing their work. We have been fortunate to have the renowned personalities from academics, industry, and other areas, and we are sure that the Center for Climate Change and Water Research will continue to get significant provision from the diverse groups in the near future C3W events. We are very much thankful to Honorable President Sir for his motivation and guidance, and we are also thankful to our Honorable Pro-President Ma'am, Dr. Ritu Galhotra, for his encouragement and providing all the necessary facilities to make a grand success of this event. Now, I would like to thank Dr. Shruti Ganga, Coordinator, Center for Climate Change and Water Research, for her leading supervision and inspiration at every point of this event. I would also like to gratefully thank Dr. Suraj Kumar Singh, Sir, Coordinator, Center for Sustainable Development, for his enthusiastic support and valuable suggestions during the entire convention. A special thank to Mr. Pranay Devate, Assistant Professor, C3WR, Mrs. Priyanka Roy, Assistant Professor, C3WR, and Mr. Rishabh for their unflinching support and coordination to make it a grand success. Now, I would like to thank the media persons and those who have directly or indirectly involved in the success of this C3W 2020 event. At the last, I wish you all a very happy and prosperous Diwali on behalf of Suresh Gyan Vihar University, Jaipur. With these warm regards, I move to the end of this 3 days international virtual convention on sustainability in current scenario, challenges and solutions. Stay safe and stay healthy. Thank you very much to all of you. Thanks a lot.
Priyanka, we can have a group photograph. So all the candidates are requested to please turn on their cameras so that we can store this movement. So please, it's a request to all the candidates to please turn on their cameras so that we can have a group photography. We can capture together, and after few years, long back, because all the video that we have done for last 3 days has been recorded and uploaded in YouTube. So after 4 years or 10 years, we can see what we did, what was the scene. So please, it's a request from all to please turn on your cameras for a group photography. Mr. Rishabh and Pranay, please capture it. All are requested to please look forward. Look forward. Dr. MS Khan, sir, I can see you. Sir, please, if you can have a frame where you can see front towards the camera. Please confirm, Pranay, if you have taken the photograph, and Rishabh.
Yes, sir, taken, sir.
Okay. Priyanka, you can seek permission from President sir and Pro-President ma'am for the close of this convention.
Thank you, sir. President, Honorable President, sir, and Honorable Pro-President ma'am, I seek permission to officially close the session.
Maybe they left.
Thank you.
Okay, I seek permission from Dr. Shruti Ganga and Dr. Suraj
Yeah.
Have a nice day.
We are officially
Thank you very much to all of you.
C3W 2020. All the recordings are recorded already. The day 1 and 2 sessions, paper presenters, recordings have been uploaded in YouTube. You can see recording from the entire day. And today's recording will be uploaded soon. By evening, we'll upload. And once we'll complete this session, conclude this session, you'll be getting a feedback link in your email ID. On filling it, you'll be getting your certification for the participation for this conference, and the candidates who have participated and who has presented will get a presenter certificates. So the students who have participated will get a participation, and the presenters will get a presenter certificate. And the candidates who have got first, second, and third prize will get a special letter of acknowledgement and recommendation by the conveners and co-conveners of the convention. Thanks a lot. Have a good day. Be safe. Hope to see you in C3W 2021. Have a great day. Have a great future.
Thank you, sir. Thank you, sir. Thank you, ma'am. Thank you, sir.
So it's a request. Please all log out from this session because it's take too lot time to get it log out. So it's a request.